All right, good morning, everyone. Again, my name is Josh Bragg. I'm the Bituminous Technical Services Manager for GDOT. This presentation is going to be about the importance of properly cleaning and tacking before placing a new pavement. Typically, you will have two different types of surfaces that would need cleaning. You will have a mill surface and a non-mill surface. A mill surface is probably the most difficult to clean. If you notice behind this milling machine in this picture, you have a lot of fine particles and dust that is left behind on the roadway. This fine material can be difficult to get up if proper care isn't taken. In this photo, you will notice how a mill surface has been properly cleaned and there wasn't any fine material left on the roadway. Also, look at the vertical face in this picture and you can tell how it's been cleaned properly. During cleaning, you want to make sure you had the proper equipment needed to clean the roadway. You should have at least one power broom and a power blower or a combination of the two. A vacuum truck is also a good tool to have on milling projects, especially on interstates and deep milled areas where you had nowhere to blow the material. You want to make sure you remember when you're checking the roadway to see if it's been properly cleaned that tack will not bond to a wet or dusty roadway. This is just showing you a power broom that's mounted on front of a tractor that's used for cleaning the mill area to ensure an adequate bond will be made when tack is applied. A power broom is a must-have and works really well when cleaning a roadway. This is a power broom pushing the material off the road. When doing this, you want to make sure the material is pushing the right direction and not towards traffic. This is an example of a power blower used to clean the mill surface on the interstate. This does really well in cleaning the fine material that is left behind. Here again, you need just to make sure when you blow on the material that you blow it away from traffic. Another option for cleaning is the vacuum truck, as I mentioned earlier. This works really well in deep inlays where the material can't be distributed off the roadway. This is on an interstate where they are using multiple brooms and a vacuum truck. This allows them to clean properly in a short amount of time before a lane needs to be reopened to traffic. Sometimes in small areas, a hand broom will be good enough to clean the surface properly. In this case, the contractor milled a small area to tie the new asphalt into. Traffic is the best way to clean the mill surface. Even using the power brooms and blowers, it can still be difficult to remove the fine material and dust that's left behind. This could be an option to discuss in pre-construction meetings to see if the milled area can be left open to traffic for a couple days to help with cleaning the dust that's left behind. Next, we're going to move on to tacking. Tack is used to bond layers of asphalt together and is governed in GDOT specifications section 413. Before tack is applied, you want to make sure the surface isn't wet and is clean from the debris. You also want to make sure the tack coat is applied with a distributor truck and you coat the entire area to be paved. In small areas not accessible by a distributor truck, you may use hand hoses. Just remember once the tack is applied, not to allow traffic on it to prevent tracking debris on the new tack coat. Some of the concerns with tacking go back to making sure the surface is properly clean. Other things to look for is the surface must be dry. Tack only what can be covered in the same day. Non-uniform shots, puddles of tack, tracking tack, your incorrect width or alignment, tacking vertical faces, and over and under tacking. This is an example of a distributor truck that is commonly used today. This is a spray bar that's located on back of the truck. Sometimes the nozzles on these spray bars will leak. So when they're not spraying tack, they need to park the truck off to the side to prevent tack puddles on a newly surface. A distributor truck needs to be equipped with a tank heater, a thermometer, a travel speed indicator, a pump tachometer, and a pressure meter, positive shutoff controls, hand spraying equipment, a sample valve, adjustable spray bar, your proper spray nozzle size, proper spray nozzle angle for the overlap, product level indicator, and an outage gauge. This is your product level gauge. This truck has about 1,850 gallons of tack. This is the controls inside the truck. Here you can cut off certain nozzles, adjust your pump speed, and adjust for the correct alignment and width. This is the sample valve that's located on the bottom of the tank. Test and management obtains samples out of this valve twice per week on interstates and once per week for other projects. The tank on the tack truck should have two ways to check the temperature. There should be a dial thermometer and a mercury thermometer that is recessed in the side of the tank. You notice here. If you look closely, the thermometer is showing about 325 degrees Fahrenheit. Based on this temperature of this tack, would this be an asphalt cement or emulsion-based product? If you would, just use your Q&A, and if I got any questions, anything, if you don't mind, use that Q&A to answer the questions. So in this tank here, if this is 325 degrees, can somebody tell me if this is a asphalt cement or emulsion-based product? Yes, that is correct. It will be an asphalt cement based on that temperature. Asphalt cement temperature needs to be between the 350 degrees to 400 degrees Fahrenheit, as is shown in the picture before, and emulsion needs to be between 140 to 180 degrees Fahrenheit. Also, make sure you don't heat the emulsion over 180 degrees because this can cause it to be unstable and begin to break or cure in the tank. The nozzles need to be the correct size for the material, or the pump pressure needs to be adjusted properly to obtain a uniform coverage. Also, make sure the nozzles aren't stopped up and are adjusted at a 30-degree angle to obtain a proper overlap. This is a diagram showing you the different types of nozzles and their application rates. And this picture is a multi-material nozzle, and this is the most commonly used. Both GDOT specifications, section 413 and section 400 have tables for the tack spread rate. This is the table for the bituminous tack, so you want to make sure you're looking at the right one for the material you're using. You also want to make sure you pay attention to any notes they may have at the bottom. This is a table for emulsion spread rate application. Emulsion consists of a binder, a water, and emulsifying agent. When emulsion is applied, you have to wait for it to break or cure before you begin paving. This allows the water to evaporate. When you first apply the emulsion, it will have a brown tint, and when the water evaporates, it will turn black, indicating it has broke or cured. Here again, you also have notes at the bottom, so make sure you pay special attention to those. Does anybody know why we have a higher tack spread rate underneath OGFC? Again, just use that Q&A feature. All right, hopefully I ain't bored y'all to death already. Y'all asleep. It's too early. Be sleepy. All right, I ask it again. Does anybody know why we have a higher tax spread rate underneath OGFC? I give y'all a few more seconds. Yeah, somebody says it helps seal out the water. That is correct. This higher spread rate prevents water from saturating into the underlying layer, so it would drain off the roadway. In this picture, you can see how the water has drained through the OGFC and off to the shoulders. This helps prevent overspray on the windshields when it's raining. And the OGFC is mostly used on the interstates. They are few state routes with high traffic volumes that it's used on as well. For people who don't know, OGI stands for open graded interlayer. We use this mix for crack mitigation. The higher spread rate of 0.08 to 0.10 gallons per square yard is used to try and get more emulsion down in the cracks to help seal them off before the OGI is placed. This is a video showing you how tack is applied. The brown paper was put down to prevent overspray on the existing mat and to give the tack truck a little leeway for the pump to prime before it's applied. When tacking, you want to inspect the shot for the correct width and alignment, uniformity, streaks and puddles, vertical joints, the spread rate, and a proper PG grade. Can anybody tell me why this shot wouldn't be acceptable on a mill surface? I repeat the question. Can anybody tell me why this shot wouldn't be acceptable on a mill surface? That is correct. They did leave out the wheel pass, but also the actual tack that's on the roadway itself, if you notice, it's real stringy. It don't have a good uniform coverage and overlap. In this case, the nozzles are probably stopped up, so you need to get with the tack truck driver and just make sure the nozzles are clean, and then make sure they taking the wheel pass as well. Contractors used to leave out wheel paths to prevent tracking on the equipment tires and it falling off and being paved over. In this case, this will leave tack puddles in the mat. To prevent this, very good cleaning is the best and only way. So this is something you have to be mindful of on a mill surface. This is a section where the contractor left out the wheel paths and then were made to tack full width. This is cores that were obtained in the wheel paths without the tack that showed the lamination between the layers. There's also been some research that has been shown that these areas are more prone to crack due to the delamination. So this is a very good reason to make sure they are tacking these wheel paths. You want to make sure the vertical edge is tacked properly and not oversprayed on a horizontal surface. If you notice here, they actually are using a hand hose to make sure they properly place the tack on the vertical face. Can anybody tell me if this is a good tack shot? Yeah, somebody said no tack coverage in the wheel path. I think they actually in this photo here, they was just trying to tack that vertical face. They hadn't tacked the other section of the roadway yet. But this wouldn't be acceptable. This vertical face doesn't have any tack applied to it. So you want to make sure the tack truck driver does apply a tack to that vertical face. How about this picture? Somebody tell me if this is a good tack shot. Yeah, I think somebody's saying that they actually tacked too far into the other lane. They had too much overspray, and that would be correct. But also, it's a little stringy, so there's probably some nozzles that's not spraying correctly. So you want to make sure they have the nozzles clean to give you that proper overlap. Can anybody in these conditions that's listed here beside this picture tell me how long it would take for this to emulsion to break? I figured there may be a little bit of delay when I'm asking all these questions, so I ask it again. Can anybody tell me how long this tack shot emulsion would take to break in these conditions? Yeah, somebody said about 15 minutes, and that is probably about correct. And the reason for that is because you got a pretty warm temperature and a low humidity. And these two pictures here, can anybody tell me which emulsion has broken or cured? Yeah, somebody's saying the one on the right. How come the one on the right? I mean, what can you see in this picture that's letting you know that it's already cured or broke? That is correct. It does have the black tint, so that's a good indicator that the water has already evaporated. If you notice in this picture on the left, it has that brown tint, so there's still water present. This is what happens if you put equipment on emulsion before it breaks. It will pick up on the equipment tires. So again, this is when you want to wait to make sure the emulsion turns black before you put any kind of equipment or start paving on top of it. This is another reason why you have to wait for the emulsion to break. This core, the laminated after being cut, if you look closely, you can still see the emulsion has a brown tint. You see this brown color here where the core was taken. We're gonna move along to some construction issues. Can anybody tell me what is going on in this picture after the roadway was milled? That is correct, scabbing. You have scabbing where a layer of asphalt wasn't removed completely. If you notice here in this picture, if you see this, you want to mill deeper to completely remove the layer. Can anybody tell me if this and is the final mill surface, how will this variable profile and scabbing will impact bonding? All right, I'm gonna repeat the question. Can anybody tell me if this is the final mill surface, how would this variable profile and scabbing impact bonding? Yeah, somebody said it won't bond. You will actually bond to these scabbed areas, but you wouldn't want to place asphalt on top of this because the scabbing is delaminated from its underlying layer and eventually will come loose, creating potholes or other issues, including cracking. This is showing you how the new asphalt bonded to the scabs, and you can take a shovel and scrape underneath the scabbing. This is why you want to make sure you mill deep enough so you remove their entire layer. This is a emulsion tack shot that was rained on. When the emulsion gets wet, it will turn back to a liquid state. In this case, this was a pretty much a heavy rain, and it pretty much washed away the emulsion that I had already sprayed. This wouldn't be acceptable. Tack would not bond to a wet surface. In this picture, after the tack had cooled down, he was able to pull it right up. If you notice, he was pulling on it here, and it's pretty much like a piece of bubble gum. Can anybody tell me what has happened in this picture? Yeah, can anybody tell me what has happened in this picture? That is correct. They did drive across the tack, contaminating it. This will need to be cleaned very well before asphalt is placed on top of it. Again, tack would not bond to a dirty surface. So this is why you want to make sure it stays clean. Does anybody think this vertical face should be clean? Yes, this vertical face should be clean. This debris would affect the bonding between the two layers. If this was on your project and you saw this tack shot, what do you think you should do? Yeah, if somebody said check the nozzles and respray, yeah, that'd be exactly right. Just want to just make sure the nozzles look like they stopped up again. So make sure they're good and clean, and you get that good uniform coverage and that proper overlap. What do you think you should do in this situation? Okay. Does anybody know what you should do in this situation? Yeah, somebody said pulling and adjust the nozzles, maybe spraying too much, and that would be correct. Also, I mean, just I, you want to make sure you check your spread rate. Also, they may be using a too much of a higher spread rate. And in this case here, I mean, once you tack it this much, there's really not too much you can do except mill it and replace it. This is a tack shot that was sprayed too heavy and covered up. If you notice the shiny appearance, this is where the tack has started bleeding up through the asphalt. The only thing to do here is to mill and replace it. You think we need to mill and replace this area here? Yeah, this is another section where you're having a too heavy of a tack shot, so it does need to be milled and replaced. This is another example of a heavy tack shot. If you notice, you got a shiny appearance in these wheel paths. This will be an area that will need milling and replacing. The shiny section you see in this photo is actually a hydraulic spill from a piece of equipment, and it was paved over. Any types of oil or fuel is detrimental to asphalt. In this case, this should be milled and replaced. How about this section here? Do anybody think we should mill this? Yes, this should be milled. This is a fuel spill from an accident, so it had to be removed and replaced. This was from a poor bond between two layers. When the roller was rolling it, it caused the asphalt to push out and tear. This is a reason to make sure you have a good uniform tack shot. This is where the asphalt was slipping under traffic between lifts. This can be a result of both too much tack or not enough. Some of the key takeaways are to make sure you properly clean the surface and apply a good uniform tack shot to both your horizontal and vertical faces. Just remember the newly placed asphalt is only as good as what you place on it. What you place it on. Again, we have technical services personnel out in each district. So if you see something that doesn't look right or just need a second opinion, feel free to give them a call or email, and we'll be happy to come out and assist you. Does anybody have any questions? All right, if we don't have any questions, our next presenter is going to be Will Rogers, and if y'all just give us a couple seconds, he'll be coming up next. And thanks again for attending the class today, and I hope everybody gets something out of it.
All right. Top of the morning to everybody. And this is what it looks like when you forget to change the year on the front slide. I do know that if it was actually back in 2022, I would make some different investment decisions. But let's go ahead and get started talking about the functions of the paver. So the paver has been around for a little while. This is kind of what an early one looked like. I don't have one with pictures of being drawn by horses, but they do exist. So here's basically the idea of a paver. You've got a tractor, you've got a hopper up front where you can dump the material. Material is going to go underneath the tractor, and it's going to go to the screed plate that the tractor is towing. And you can have really old ones. You can have ones that look like they came off of a farm or the town of Ellicottville. And you also have really small ones. This one actually is a paver that was used um, on shoulder work. So that's usually pretty narrow. And so this paver was used, I think, on I-16 or a paver like it on I-16 to do some of the narrow shoulder work there. You see the hopper looks a little bit disproportionate to the rest of the machine. But generally speaking, whether it's small, whether it's big, whether it's parking lot, whether it's highway, you've got the tractor unit and you've got the screed unit. Together, it's the paver or the spreader, however you want to refer to it. And material is going to get dumped from either the MTV or the truck into the hopper, and it's going to be carried back by some form of slat system to the augers behind the tracks or behind the wheels. The augers are going to take that material and spread it out. Augers turn on and off based off of some sensors that we'll look at. And then once you have a constant head of material, you move forward and you've got a good paving mat coming out behind you. So a couple things that you need to understand about a paver if you're going to understand how it's really working. One, that tractor is self-leveling. I'll show you a picture here in a second. But what that means is the screed is free to rise and fall as it goes over uneven terrain or as it has more material under it. And there's a constant line of pull on the screed when it's set up properly. And this is what provides us a smooth surface over irregular grades. So if you take a look at this, this is just kind of, you got a single wheel paver, you got a bogey wheel paver, and you got a flexible track paver. That tow arm is attached. I don't think you can see my cursor, but that's okay. You can see kind of where the tow arm is attached to the screed or tow arm is attached to the tractor. That's what's providing that line of pull because it's only being pulled from that one point. And so you've, like I said, bogey wheel, single wheel, track paver. The one thing that you want to make sure, if you've got an operator that's really good at a wheel paver and you put them on a track paver, the track paver kind of drives a little bit more like a bulldozer than like a car. And so you can have sharp turns this way and that way. And so it is a slightly different skill set. Don't expect someone who's great on a wheel paver to jump right on a track paver and get it perfect the first time, the first moment that he's paving. So basic principles. So if you've ever bought a house or if you've ever listened to anyone talk about real estate, the number one rule of real estate or the top rules of real estate are location, location, location. So for paving, the top rules are consistency, consistency, consistency. Same idea. You want to keep a constant head of material in front of that screed. And you want to keep your augers running constantly. So here we've got a picture. Basically, it's kind of showing the slats taking the material back to the augers and the augers throwing it out in front of the screed. That material that the augers kind of buried in, that's right in front of the screed, that's called your head of material. You can have more material there, you can have less material there. We'll talk about how much exactly you want. but you want to have a constant head of material. If you have an increase or a decrease, it's going to cause the screed to rise or fall. It's going to cause some streaking that we'll get into. But at the end of the day, consistency, consistency, consistency. And so you want that constant control of material from front to back and side to side. And you want the head of material to be roughly even with the middle of those augers. You can be a little bit higher. I don't really want it to be much lower, but that's a good target to be shooting for. So how this works, this is an older paver, but the idea is pretty much the same. So we're looking at the hopper end, and those slats on this paver will move continually, and then the way the material is taken back to the augers is it has to pass those flow gates, and those flow gates are what goes up and down and controls your head of material. It works different ways in different pavers. This is a Vogtle paver that looks like a transformer, looks like an angry transformer. What you'll notice is that there are no flow gates there. And that's because those slats will actually move at variable speed. And so that's the way this paver controls it. Different ways to skin the cat, basically the same idea. Before I go any further, I did want to mention there's a delay when we were taking questions in the last presentation. There's a delay on getting the questions between 30 seconds and a minute or 2 minutes, it seems like for some. So I'm not going to take any questions through the chat pod. If I ask a question, feel free to yell out the answer. And let's see if we can get your coworkers and supervisors to think you've got some form of asphalt-related Tourette syndrome. And just see everyone's yelling out AC or constant line of pull. See if we can confuse everybody else and wonder what's so cool about asphalt. All right, so moving on. Again, this is just the different ways to skin this cat, flow gates or variable speed slats. At the end of the day, you want to control that head of material. The way you're going to do that is you're going to control how much material is coming back to the augers. You're going to control your paving speed, and you're going to control your feed sensor, your auger sensors. And when they're set up properly, the material is going to be at the center level of that auger, kind of like I mentioned earlier. And you want your augers to be turning 100% of the time. You don't want them to be turning 100 miles an hour 100% of the time, but you do want them to be continually feeding new material. And so you can look at this, and if your flow gates are set too low, you're not delivering enough material, your slats are moving too slow, your augers are moving and they're moving material out, you're going to have this void underneath the center of those augers, and that's going to lead to some volume and some density and consistency, some streaking, and we'll take a look at what some of that looks like. But how do we get our augers moving appropriately? I'm glad you asked. The answer is we have a sensor. And so this little green box, so the rectangle at the bottom is kind of your screed plate or your end gate, and then you've got your auger, obviously. That green box sitting on the end gate is the sensor, and the blue cone is kind of the area where that sensor is detecting. And you can change where that cone is pointing, and that will change where how your augers are going to move. You can also knock the sensor inadvertently and change how your augers are going to move. So you want that to be on the active material so that it's not just going 100 miles an hour or not going at all. And we'll take a look at some of what that looks like. So you can have a variable width pulls, so you can move your end gates in and out. You can have extendable screeds. At the end of the day, you want your augers to be within about 18 inches of your end gate when you're doing a constant width pull. So you have auger extensions that you can add onto there, basically so that you're not trying to throw the material, 4 feet, 3 feet, whatever. So this is the back of the paver. We've taken the screed off, so you can see the slats. You can see the hangers, or the hanger bearings, and the actual augers. And those do go up and down depending on the thickness that you're paving. Typical, if you're paving in 25, it's going to be higher up than if you're paving in 9.5. And that inset picture is showing that there are adjustments you can make to that auger, or add-ons you can have with the auger that will actually throw a little bit of material back under the center so it doesn't starve that area. All right, so, oh, I'm sorry. One of the things that you'll see, or one of the things that you don't want to see, is streaking from your hanger bearings. You know, this will let you know that, you know, you got too much material in there. Your hanger bearings are pressing into the mix, and it's kind of pre-compacting that area. And you can have different issues going on there, but it will lead to some density issues. It leads to, you can see this mat, it just doesn't look that great. And if you were to pop cores across there, you'd probably have some differences. And so if you see that in the field, you'll want to look at, okay, are those streaks coming right behind the hanger bearings? So remember, here are your hanger bearings. There's the center pylon that's holding the entire assembly up. If you're getting streaking behind these points, then you've got some issue with your head of material, with your augers moving. That's where you want to look to try and solve your problem. So you can also have, we've mentioned incorrectly adjusted. You can also have worn augers, and it's going to influence the texture. We've kind of explained kind of why you can have a void there. You know, if you're starving the center section, you can have a streak underneath the hanger bearing if you've got too much there. The one thing I do want to make sure that I touch on is, I said you want an auger extension to be within 18 inches of your end gate on a constant width pull. So this project was on, was it US 129, and this was not a constant width pull. So these guys are pulling, I think this was a turn lane, and they're just starting to turn to pull off of the. Okay. Not sure what that is. They were just starting to pull off of the concrete. So you see here, I'm going to play this video. See the paver starting off, end gate just striking it, or the strike off, just striking it off. It's not compacting it like the screed is. You see him bumping it in, because again, this is not a constant width pull. But you see those augers are still moving still. And on a variable, on a constant width pull, you don't want to try and move that much material that far. You can wind up with segregation. On a variable width pull, there's not really much in the way of a choice. It's actually worse to try and pull a little bit, stop it, pull off the bolt-on, pull off the auger extensions. You know, it just doesn't work that well. So let's see. Next, this is the same pull, and here you can see that little shiny box is the sensor. And I'll get this started. So this is the same pull, same machine, same crew, same night. And excuse me, what you'll see back here by this end plate is that there's material that's not moving. By that strike off. That gives you a good idea of why you want, on a constant width pull, why you want to have your augers closer to that end gate. So you've got material that it's not moving, and it's eventually going to get cool, and then it's going to get cold, and then it's going to break off, and you're going to have an issue in your mat, especially, you know, if it's been there for a while and then you bump the end gate in or out and you move something, it's going to break loose and you're going to have an issue. So you always want to just make sure that your augers are appropriate to your end gate on a constant width pull. All right, so what else should we use on a constant width pull? Feel free to yell out an answer. I'm not going to take it through the chat pod because that'll take a couple of minutes to get the answers. Excuse me. But basically, this is a wedge lock screed, And if you're going to use a constant width pull, you don't want to have just a strike off. What you want to have is a bolt-on extension. And you can see these three very large bolts, which give it the very clever name of bolt-on extension. And this basically goes on the end of your screed, and it gives you, an extra foot, an extra 2 foot. And we'll go through a number of the things that you want to do on your screed plates as far as angle of attack and things like that. We'll get into that, but just know that when you use a bolt-on extension or use bolt-on extensions, you have to do the same thing on those. You have to make sure that those are still in the same line, in the same plane, at the same angle of attack. But you see that pre-strike off plate, and the main screed plate has one of those as well. One thing that you do want to make sure of, you have a curved plate like what this one is, but you can also have a straight plate. And you're going to want to make sure that your bolt-ons match your main screed plate, so that you're not trying to have a curved strike off or pre-strike off and then a straight strike off, because you're going to get material caught in there, and you're going to see that in the mat. All right, so what's missing from this picture? Again, this is where you just yell out of the screen. So this is the screed, and we've taken off the plate, the actual screed plate. So you see it is pretty beefy, pretty hefty, what's holding that piece of steel on. And speaking of that piece of steel, so this is a screed plate. I want to note a couple of things about this as we're looking at it. One, it's big, it's heavy, and it's steel. You see the front end is closer to the guy standing there. It's the end that curves up. It's got a bull nose on the bottom. That's the front end of the plate. The tail end of the plate is obviously the other end. Now the bull nose, or the leading edge of that plate, does have a cut in it. And just note that cut. We'll get back to that in a minute or so, but just note that that's there. And one of the things I want to make sure that you guys understand is the difference between, say, a highway paver like this one is behind this gentleman, and then the plate, and a parking lot paver. So a parking lot paver is going to be a lot smaller, and so that's going to make it a lot more reactive, which is great when you're dealing with, turning around islands in a parking lot, or trying to match this, match that in a tight distance or a tight spot. But it's bad on a highway paver, because that same reactivity, that same ability to react so quickly, is going to really affect your ride quality. So that's why highway pavers have such a large and heavy screed plate. So this, it's always hard to read this one if it's 1/2 inch, 3/8 of an inch. But this is the new screed plate, and it's beefy. You're not gonna, if you can lift that, come over. I've got some housework and some yard work that needs to be done, and I could use the help. This is the old screed plate that was taken off, and you can see that the tail end of that screed plate, which is what they're holding up, is a lot narrower, and it'll actually get pretty sharp if you let it go. Don't let it go. You'll have some issues. So remember I told you when we looked at that screed plate that we'd come back to the fact that the bull nose had a slit in it. So the reason that it's got that slit is so that you can basically break it, not break it all the way, but you can basically flex it, and you can put crown into the road. You can do positive crown, or you can do negative crown. Don't do negative crown. The only time I've seen negative crown that I could maybe understand it is in a parking lot. But again, don't do negative crown, because basically you're making a place where your roller is not going to be able to really get at that center part and compact it. And if you're trying to channel water through a place that's not well compacted, it's not going to end well for you. You're going to have some maintenance issues. So we always want to have positive crown. That way we can roll it down, we can roll it properly. Your factory set is going to have your lead crown at 0, and you can have, because you've got that slit, you can adjust the lead end of that plate, but you can also adjust the tail end of that plate. And here's how you do that. There's a chain with a little wheel on it. Turn that, and I'm sure there are different ways for each different ways to skin the cat, but this is the basic idea. Is you can just go and adjust it, and it is fully adjustable. So you can have lead crown and you can have tail crown. You can adjust both of them. The rule of thumb is you always want more lead crown than tail crown. And if you think about just kind of the what's happening there physically, if you have more lead crown, then you're basically able to funnel more material more smoothly into the screed plate. And if you have more tail crown, then you're basically closing off that front part of the bull nose or the front part of the screed plate. And so you're going to get some texture issues because you're going to be starving the back end of your screed plate. And so here's kind of what that looks like. I hope you really appreciate all the effort we put into some of these pictures. They are just top notch, well used. We'll put well used. So if you look in section A there, you've got the lead crown too high. And so basically you're shoving too much material down the center of that screed, and the edges of your screed or the other sides of the screed are kind of starving. And so they're going to have a loose mat and you're going to have a bright streak in the middle. Now in section B, it's kind of the other end. You've got your lead crown too low, your tail crown a little bit too high comparatively. And so you're going to get material throwing or starving in the center and moving towards the side of the outside of that screed plate. So you're going to get loose material in the center and bright streaks on the back. And if you have uniform matte texture, you've got a good lead crown and a little bit more tail crown, everything's appropriate there. You can get a uniform matte texture and you have proper flow through the screed or underneath the screed plate and then out of the back of the paver. So there are two things that we've talked about so far that can adjust or can affect the texture of the mat that's coming to you, or that you're going to get out of there. And that's your head of material, which is very important. You can have your hangers start streaking, but you can also have issues with the screed plate. And just pay attention to what the mat looks like as it's coming out, and even what the mat looks like after it's rolled, because some things, can be rolled out. If you've got your end gate out and you just got a strike off, that texture is very different. It's not pre-compacted at all. So after it's rolled, and it's rolled properly, everything looks good. So pay attention to what the mat's looking like, and you can use the mat to actually diagnose what your issue may be with your paver, if you have an issue with a paver. So we've talked about those two things. So here are the primary factors. These are the things that if you do nothing else, these are the things that are going to have the biggest swing on your mat quality. So remember kind of what we've got here. We've got this free floating tractor on a tow arm, and it's being held up by that one tow point. So the angle of attack is what we call the angle that your screed plate makes with the ground or with the surface that you're paving on. So if your angle of attack is too high, you're going to wear out the back of your screed plate. If it's too low, then you're going to wear out the bull nose because you're basically dragging it. Second thing, which we've already talked about, is the head of material. I won't go too much more into that. But the third is paving speed. If you're starting, stopping, you're going to have issues. Remember, the number one rule of paving, the number two rule, and the number three rule. It's all consistency, consistency, consistency. And so consistent head of material, consistent angle of attack, consistent paving speed. Now the angle of attack is what you're going to use to adjust the thickness of the mat. So if you increase your angle of attack a little bit, you can get a thicker mat. Decrease it, likewise, you get a thinner mat. So let's see, you always want to have a nose up attitude when you're paving. If you're leveling, that's a different issue. But when you're paving, you want a nose up attitude, and your screed is going to reach equilibrium. And your typical angle of attack is somewhere between an eighth and a quarter of an inch. Too low, and again, you're going to get pulling, tearing, wearing on the bull nose. Too high, you're going to get the screed compacting with and wearing at the tail edge. So again, when we saw that screed plate be taken off and it was worn on the back end, the tail edge, that can give you an idea of how the paver is actually paving. And when you go out and you inspect your paver in the morning before you start paving, take a look and see, okay, am I seeing increased wear in one place or another? Because that's where I'm putting stress that I don't want to put, and that's going to impact the mat. So again, it's very complicated how we adjust this. turn one way and it goes up, turn one way and it goes the other way. Very, very complicated. So I've said this is how we adjust thickness. Basically, we adjust our angle of attack. A lot of times there's this desire to see that adjustment take place immediately. It's not going to take place immediately. If you make an adjustment to your angle of attack, you're trying to adjust your thickness, then that's going to take 5 lengths of the toe arm to fully come into effect for that screed to reach a new equilibrium. So 65% of that change is going to occur within the first length of that toe arm. The rest of the 35 is going to go over the last 4 lengths of the toe arm. And this is something that will greatly affect your rideability, how smooth your pavement is. If you're over there every length of the toe arm, just turning on the thing, trying to get it to go this way, and then you overshoot and you turn the other way. When you make a change, give it at least 5 lengths of the toe arm, and then give it a little bit more just to see if you're happy with it. You know, if you look up and go, okay, I'm still too thin, still too thick, okay, I can make an adjustment. But don't try and make that adjustment on the fly. You know, another thing that you can see about some parking lot pavers is a number of parking lot pavers have shorter toe arms. Not everyone by any stretch, but take a look at the toe arm and you'll get an idea of how reactive that pavement or that paver can be to making a change. Okay, someone's got a question about this one? What's my question?
Question is the angle of attack dependent on the mix type?
The angle of attack, not really. I mean, your head of material where your augers are is going to be dependent on your mix type because that's going to have to do with your thickness. Your angle of attack ultimately is going to have to do with how thick you want to pave. So in that sense, you know, kind of you want to reach an equilibrium, but you also want to reach a you also want to have a good mat material, a good mat coming out of the back of the paver. So if you've got issues with pulling and tearing or something that could be due to, you know, the type of material you're placing or the nominal maximum of the mixture, you know, I'd look at the whole thing before I just say, okay, the angle of attack is obviously wrong. You might have some strike off issues. You might want to adjust your strike off, your pre-strike off. If you're set up for a 25 millimeter mix and you're paving a 4.75, you know, it might need to be a little bit lower. But it's something to look at, but I'm not going to sit there and say that, you know, your angle of attack is going to be drastically different. So your strike off settings do affect your angle of attack because that strike off plate, remember we looked at this on the bolt-on extension. So that's going to basically strike off the head of material. So not the entire head of material is trying to move underneath that bull nose and underneath the screed at one time. You've got to strike off. And here's where I was saying that, you know, if you've got a 25 versus a 4.75 millimeter mix, you might adjust your pre-strike off because that's going to affect how the material comes to the screed plate. Let's see. So your strike off is adjustable. You can set it too high and wear your bull nose. You can set it too low and trap rock under there. And then you also get some wear and tear on the tail end of your screed plate. And so that'll depend on your mix type. So here's what it looks like when strike off is too high. So he got wear on the nose of the screed, and he wound up with poor mat texture. The mat's going to tell you a lot. The mat's going to tell you an awful lot about what's going on in that paver. You know, we've shown kind of picture of what it looks like when you've got loose texture here, tight texture here, when you've got a streak here or a streak there. Understanding what's actually going on in that paver really, really helps. So there's one thing about the screed that we haven't really talked about, and that's temperature. If you've been on a paving job, you realize that stuff is, you know, if you're dealing with the 6422 binder or 6722 binder, which is under 25,000 vehicles per day mostly, you're about 300 degrees coming out of the plant. So it is, let's say it's warm, a little bit on the hot side. So we do actually have heaters on these screeds. And this was actually taken with a little FLIR thermal camera, and it's one of the things that you can go plug into basically your iPhone. Costs 200 some odd bucks. Which, when you consider the fact that 15, 20 years ago they were 25,000 bucks, they're pretty cheap now. But you see that there's a yellow streak on the side and a bright yellow streak on the other side, and a slightly cooler streak in the middle. Now in this one, they were just getting started, and this particular screed plate was I forget the name of it's a Roadtech screed, but I forget the name of the actual plate or the model number. But it doesn't have a heater in the very center, and it relies on conduction to heat the rest of that center of that plate. And before we had heaters, you'd have a whole bunch of people with lit coals on their screed plates. A little bit safer to have some heaters. But what'll happen is when you see something like this and you're starting off, you think, oh wow, that's almost a 30-degree difference. When we rolled that out, we found that we didn't have a difference in density, we didn't have a difference in performance. And then as we kept moving through this, it heated up, and that difference kind of disappeared. And that was just because it was that type of screed plate. So even if you do go out with a thermal camera and you see a thermal difference, don't immediately freak out. You see 28, 30 degrees, you think, oh, that's going to be a problem. Not necessarily. So just know that these things do have heaters on them. Different manufacturers, arrange their heaters a little bit differently. But if you see something that's concerning, talk to your contractor. Say, hey, this is what I'm seeing. Is there a reason for it? Don't immediately just kind of, holy cow. Excuse me. So there are different types of screeds. We've talked thus far about wedge lock, which is kind of the traditional thing that's been used in Georgia for forever. Fixed width screed, and that's where you use a bolt-on extension to increase your constant width pull thickness, or not thickness, but width. But you also have extendable screeds. And these are very, very cleverly and dastardly named. Front extendable screeds have the extension plates in front of the main screed, and rear extendable screeds have the extension behind the main screed plate. And very, very crazy how they did that. We're sneaky with how we name things. And we're seeing more of these in Georgia. Give you kind of a look behind the curtain. Most of the most states, I think Georgia is maybe the only state that uses predominantly wedge lock screeds. And so a lot of the manufacturers have kind of come to us and said, you're the only one doing this. We may not be making these all that much more. So you might want to look into something else. So we're seeing some more extendable screeds come into the market. And the extendable screeds, not the devil. It's not bad. It's kind of like an emulsion tack. It's not a bad product. You just have to know how to use it properly. So this is again just showing the different screed types: the front extendable, rear extendable, and the more conventional fixed screed. And we looked into these probably about 20 some odd years ago. And the main thing that we were interested in was pulling the shoulder and the main line at a different cross slope. So here you can see they're pulling at a different cross slope. And you can just break that extension over, and you can do 4% on the main screed, 6% on the extendable. And it makes it a lot easier from a constructability standpoint. We did notice at the time we had a number of what we call double screeding. So you see the shiny part, you see coming at kind of at the end of the main screed, where the main screed and the extendable screed are both kind of touching the mat. So it's a place where two screed plates compacted, and we had some different densities. We had some issues, and we kind of went away from using them and went back to our wedge locks. Thing to remember: one, technology from 20 years ago is different from the technology today. They've improved them. We also had a lot drier mixes and a lot coarser mixes at the time. And so they were prone to anything that was going to be doing compaction work. It was needed, but we didn't want the variability across the mat. Like I said, we're seeing more extendable screeds coming into the market in Georgia. And again, not a bad product, but the same things where you have to make sure your angle of attack is correct with one screed plate. Now you have to make sure it's correct with 3 screed plates. And with the bolt-ons, you kind of had to do the same thing already. You kind of had to make sure that your bolt-ons were in the same plane, at the same angle of attack, coplanar, and everything was working properly. But each of these screed plates is adjustable, and so you got to make sure that it just requires more than a wedge lock required. And we have contractors that have been using them straight on, and they've got good crews. And we have people that kind of like going from a wheeled paver to a track paver. There's a bit of a learning curve. There'll be a bit of a learning curve as we move more and more towards extendable screeds. I don't typically tout a whole bunch of other states, but other states use them and they don't have the same kind of issues that we've had. So I think that's largely an issue of training and having better mixes now than we did at the time. So here is what it looks like when we're doing kind of the same idea. We're pulling the main line and the shoulder together, but we're using a wedge lock, and basically they moved the end gate out and broke the end gate over, so it's pulling at a different cross slope. But you can see it's not pre-compacted with the screed. And again, we can do a very similar thing. And again, this is kind of what we were originally looking into it for, was pulling variable cross sections at the same time. We can do that with a wedge lock. It's just you got to put all of those things on, all those bolt-ons on. And you can see by the vest that this is not a current picture. So here's what that looks like. The question on the bottom of the screen is, what type of extendable screed is this? I'll let you go ahead and yell at your screens for a second. This is a front extendable because the extension is in front of the main. The extendable screeds are in front of the main screed. And again, everything's adjustable. So here's the adjustment point for the angle of attack on this screed. It'll may be different on different screeds, different manufacturers, but everything is adjustable the same as the main screed plate is adjustable. So one thing, especially the early generation of extendable screeds had that was not a good thing, is if you were waiting on mix. So especially if you're not using an MTV and you're waiting on your next truck to come and you're sitting, that screed plate, instead of being a single screed plate, is now 3 screed plates. It's a lot heavier. And so we were seeing, or across the country, they were seeing the screeds just settle into the pavement more as they were hot. And then when they pulled off, you would have this bump. So what they put in was this vertical pressure adjustment on the extensions that basically when you stop, it just kind of lifts them up a little bit. So there's not that increased pressure on the mat and causing that divot and that bump. One thing that not one thing, but just any screed that you've got, understand what it's good at, what it's not great at. Understand how to use it, how to work it. Always pay attention to temperature differentials. We talked about, there was one screed, that manufacturer on that plate was relying on conduction to heat the screed. Understand kind of what that is and what that does. I'll show you a picture here in a second of what thin lift leveling with an extendable screed did. Again, it's a lot heavier, and you turn it over on the bull nose and thin lift level, you've got a lot more pressure on that contact area, especially if you've got one of those rear extendable screeds that you can actually do that on. It just didn't work well. And then, most of our mixes we use an MTV, but if you're using a 475 or a 95 type 1, or if you're doing a small bit, you don't have to use the MTV. So always be aware of temperature. Again, consistency. So this is what it looked like. This was a brand new screed plate, had 5,000 tons of leveling over a number 7 chip seal. And the screeds were worn inconsistently. You see that bull nose is just, it's been cheese grated to death. And that's because it's very heavy. So, you know, if you have a screed that's got a little bit of technology that makes that not an issue, you know, great. But that's something to be aware of. And again, as a contractor, know your screed. And as the inspector or as someone who's on the job, ask questions. Get to know the screed that's being used. And again, everything's adjustable. And you can still put auger extensions on these for constant width pulls. You can do the same things with a bolt-on you can do with an extendable. But you want to make sure that you don't have volume inconsistencies or density inconsistencies. And if you have an issue, figure out what your issue was, what's causing it, and how you can address the issue. Again, not a bad product, not a bad paver. We use them all over the country. Just as we see more and more of them in the market, know that it's going to take, there's going to be a little bit of a learning curve as we figure out how to keep everything adjusted. I highly recommend having a daily checklist before you start paving, and just check everything on the paver and make sure that it's still in the same plane. Your strike offs are still the same. They're still the same across these screed plates. Your angle of attack is correlated, and that kind of thing. So moving away from the back of the paver, the last thing that I'm going to talk about is how we get smoothness in a paver. And the short answer is we have electronics. For the longest time, we used contact skis. So basically on the side of the ski, you would see this 15, 30, 40 foot long beam in contact with the adjacent pavement. And basically the longer what that beam is doing is it's averaging out any differences in smoothness. So if you have a bump, you're going to average that bump out over a longer area. And so you're going to have a better ride because you don't have one sharp bump. You kind of have one, did I just feel that type bump? And that's basically what we did. The longer it is, the longer that ski is, the better it's going to do that. Most of the time now we've gone to non-contact skis, and they are they're just a lot more convenient to set up because we don't have to drag it. We don't have to carry along, you know, a 30-foot beam basically. It folds out, and this is how we achieve our smoothness. So you see on this, you see the sensors on the back of this paver. You typically have 3. You have one up front, one in the middle, one in the back. We do still have some contact skis. This is not a beam, but this is still a contact ski. And you'll notice because it's in contact with a hot mat, they do have hot coals on it. It doesn't have its own heater. We do that because we don't want pulling and tearing. So still kind of have 3 sensors, and you can still get done what you need. And again, you know, just a contact ski. How can you tell if you can run a contact ski, or if you can run electronics? Take a look behind the wheel, behind the track. You're going to have this hydraulic piston, hydraulic cylinder, and that's basically what's allowing us to do this. All right, so do we have any questions? I'll give it a second. Okay, after this, we're going to do a 15-minute break. And so we will come back 10:10, 10:15, 10:15. Come back at 10:15. All right. Don't have any questions? All right, sounds like I covered the material.
Morning, everyone. My name's Tony Felix, and I'm with Reeves Construction. I'm going to talk to you today about pavement failures and deficiencies. So, whenever we think about asphalt, two of the primary concerns that people typically have is rutting and cracking. So, rutting historically was the issue, the deficiency that everybody saw more frequently and battled mostly. But over the years, it's kind of gone away, mainly because of technology, new testing, balanced mix design, and just very progressive people like Georgia DOT finding test in the design process to quantify rutting before they actually put it into place. And then increases in wrap percentages, better binders, just better materials. Not saying that asphalt doesn't rut anymore, but it's not as frequent as it used to be. So we took care of rutting, or the DOT took care of rutting, and cracking is now, I guess, would say the primary issue, which asphalt's a flexible pavement. So when it stops flexing, it becomes stiff and it starts cracking. So according to what kind of cracking that you have, it tells several different stories. So alligator or fatigue cracking is something basically that happens when asphalt outlives its service life. It's pretty much not flexible anymore. And when it's not flexible anymore, it cracks. And when it cracks, water gets into the pavement. And when water gets into the pavement oxidizes, it strips, loss of binder, loss of adhesion, and it starts raveling out. And then it's total failure. So alligator cracking, I guess, is one of the biggest fatigue crack or the most progressive fatigue cracking level of fatigue cracking that we would see. Most of the time, you'll see it in parking lots. Very little, I think, are you going to see this on any kind of DOT maintained project, unless it's just slipped through the chain. But most of the time, it's structural failures. And it usually starts with a little crack that lets a little bit of water get in, and that little bit of water gets down to the base, and then it gets through the base into the subgrade, and the subgrade starts moving and pumping, and it starts cracking more until it finally comes apart. More water gets in, the base gets softer, potholes occur, and there's really nothing you can do there but total reconstruction. Not a whole lot of ways you can save that structure of that material. A lot of it is increased loading that comes mainly on county roads or city streets, where the road started out as a horse and buggy road, may have been a surface treatment road, but over time, a subdivision was built over here, a manufacturing facility was built over there, and the loading that it was built for is drastically increased, and the road's not designed for it. And then nobody took the time to think about the road to address the traffic and the loading concerns, and it just basically got totally destroyed. Okay, so the next type of cracking that we see typically is block cracking. And block cracking basically happens when asphalt doesn't expand and contract anymore. It's not flexible. It's not ductile. It's basically hard and stiff. So there's several things that can cause this. Most of the time, it's going to be related to asphalt binder, whether it's aging, insufficient binder, amounts of binder, poor choice of binder in the mix design. So GDOT's got guidelines that basically, based on the traffic loading that the road's going to experience, what grade, what PG grade of binder to use. And they've also implemented the COAC, which is the corrected optimum asphalt content, which basically puts more need AC into the mixes based on the RAP AC contribution. So the mixes that GDOT have now, the designs that are being made with the COAC are actually richer, I think, than the original Marshall mixes before SuperPave first came in. So the use of higher RAP has actually help with the rutting issue, and then the introduction of the COAC, which only gives the wrap AC a 60% credit, has greatly improved durability and cracking susceptibility. So I think the COAC, you folks that have been around for 10 or 15 years, I think Ms. Sheila Hines brought it in 15 years ago, started out at 75%, and then 5 or 6 years later moved to 60%, which I think is a very good place to be right now as far as a balanced mix design with cracking and rutting. So GDOT has made a lot of changes, and a lot of states around Georgia and a lot of countries, actually other countries, are recognizing the COAC, the benefits that GDOT seeing from it, and the common sense approach that GDOT took to get to it is really unbelievable. Most of the time things are overthought and not practical and not that simple and that beneficial at one time. So the COAC is really taking off. So GDOT and Georgia contractors did a lot of good things together getting to that point. Now with the balanced mix design, which is the talk of the town, I know you folks that are in the industry have heard about it over and over, read about it over and over. There's testing out there that can predict cracking, that can predict rutting, that can predict stripping. It can predict permeability. So evolution has really helped us out. That evolution of all these test procedures, not just on historical data. So we're in a good place, I think, as far as the asphalt industry goes. So fatigue top-down cracking, again, most of the time you're going to see that in the surface lift, the surface layer. You'll typically see it on new construction projects or projects that were or mixes that maybe had high air voids, poor construction practices. Most of the time the cracking is going to end up being from a high air void or a segregation issue. Poor design or material quality. I don't think the GDOT's going to have any issues with a poor design or material quality just because of how they track it and the things they do to make sure that the properties of the AC, the properties of the aggregates, the properties of everything that goes into an asphalt mix is good. And as far as the designs go, their design process is very efficient. So as far as a poor design might be actually how it was built or how it's going to be built, as far as structural, would actually maybe cause that. But we really don't have top-down fatigue cracking problem, I don't think, anymore. I mean, there's always going to be that one that something went wrong on. But since the introduction of the COAC, the mixes are much richer, more durable, and they naturally crack less. So this is something that is going to happen, and this is the biggest concern or the biggest problem, or I guess the biggest challenge that GDOT, the contractors, the asphalt industry is going to continue facing is bottom-up cracking, which is called reflection cracking. There's a rule of thumb roughly that says, you cover up a crack, 1 inch in 1 year. So if you put 1 inch on top of it of more structure, then that crack will reflect through within a year, and 2 inches, 2 years, and so forth and so forth. And that might be a good starting place, but I think it's more of an assumption because every road's different. If you've got the old road was built on top of concrete, but you got 15 or 16 inches of asphalt on top of it, that crack is working a lot more from that concrete. So, we've had jobs that cracked before we even closed them out, before we could even turn around and start coming back in the other direction, to get it topped out and just the leveling was in place, the crack would reflect through. So GDOT's response to reflective cracking, again, the COAC is helping a lot. And the COAC on all the future roads, all the new construction roads, I think is going to help, 20 years from now, 15 years from now, I think we're going to see a lot less reflective cracking than we do now. But the only way to truly get rid of a reflection crack, which is all the way through the asphalt layers down into the base, and if it's a soil cement, if it's a FDR project, if it's a CMRB project that uses cement, it's going to crack, and that crack's going to reflect through. So the only true way to stop reflection cracking is to take it all up and start again. But that's not possible. Budget, it's not possible most of the time. So GDOT has got several different ways to mitigate it, and one of those being OGI, the open graded interlayer, used as a leveling and a crack relief interlayer. They use single layer surface treatment, whether 89 7s to help mitigate it. And if if it gets bad enough, I guess, and it's the right situation, and the cost allows it, fabric. So there's several options, but GDOT's got a pretty good arsenal of things they can do to help mitigate or reflect the cracking. So raveling, basically raveling is when the glue's gone, when there's no more adhesion, when the binder's not sticky anymore, and that's when the road starts raveling. Surface texture changes, fine aggregate ravels out, coarse aggregate ravels out, and then the road comes apart after that. But asphaltic cement is basically the same thing to a certain extent as Portland cement, as the marshmallows that you put in your Rice Krispies. It's a bonding, it's a glue, it's an adhesive. And when liquid asphalt gets stiff and brittle and loses bond, that's when raveling occurs, stripping occurs, and that's when the road has outlived its life. And something probably should have been done before it got to that point, but it happens a lot. So rutting, again, we still see rutting, but typically the kind of rutting that you see in these photos would come at an intersection where you've got like a downgrade area where you've got heavy trucks stopping and braking. I don't know how we would ever get through this in every situation with every project and every scope of work being different. But things that GDOT has done in the past to try to help with this is modify the mixes throughout the intersections. They've used some highly modified binders in places, but from what I can understand, the highly modified binders may have had some issues cracking, premature cracking because it was so stiff. But one of the go-tos has been modifying the surface mix, the binder, and modifying the layer beneath it, which most of the time would be your 19 millimeter. And that's really helped a lot. So I think rutting's always going to be somewhat of an issue according to what kind of job it is and what we're doing and where it's at. But GDOT does have methods to help mitigate rutting, methods to help mitigate cracking, methods to help mitigate any kind of deficiency that might happen. Just got to make sure we use the right one or use the right tool for the job, basically. So pavement deficiencies lead to premature failures. So one thing I'm very aggressive on, and I've always been aggressive on it. And when I worked for GDOT, and now with my folks at Reeves, is vision. What does the mat look like? Looking behind you. Cosmetics don't mean everything. Cosmetics don't always mean functional or non-functional. But cosmetics, it gives you an idea that there might be an issue. So most of the time, if you can see a variability in texture or streaking, there's potential for a low density area. And if there's potential for a low density area, then there's potential for premature failure in time. So, just looking behind us is, looking at the mat, just taking a ride, seeing if everything's uniform, if anything needs to be changed is a very good policy that everybody should be doing if you're in our business. So prevent the deficiency. What do we see here? So if you look to your left-hand side, you'll see that we've got two little streaks about 1 foot wide. Well, bolt-on screed extensions are basically 1 foot wide. So we automatically know that texture issue is coming from the bolt-ons. So on your right-hand side, that's pulling the shoulder with the main line, and that's addressing for the volume difference between your main screed pre-compaction and what's out on the shoulder. The screed is broke over to a 6%. They're pulling the shoulder, or the extensions broke over to 6%. They're pulling the shoulder with a travel lane, which is great because we're eliminating a joint. But what we did not do here is we did not get under the screed and check it before we started paving, which is something that we try to do every day. We've got screed checklists. We've got different policies in place where we're supposed to be checking not just every day, but checking every time we pick up and move, because things change. You may have moved from one part of the job to the other and crossed over a ditch and drug your bolt on and skewed it up on the outside. So it's very important to check it every day or multiple times a day. So bolt-on extensions, most of the time bolt-ons are more of a cosmetic issue than anything else, and there's just a little difference between elevation that typically rolls out, even though you might can see a shadow. But there are times, like you see in this picture, where the bolt on might have been digging and drastically changing the amount of volume consistency across the lane width, which may have caused the rollers to bridge over. So that's a low density area 10 years ago, and you can see where the cracks are. So that was the first part of the road to crack is where the low density area is at, where the bolt on was misaligned. So, you know, sometimes it doesn't impact you, but sometimes it does. If it's bad enough, it can really cause a problem with service life and be detrimental to what kind of performance you get out of the road. So, you know, this is base mix. You know, looking behind you. If you're on the screw, if you're operating a paver or whoever, if you're walking behind it, looking behind it, I would say this is not acceptable. That we need to stop and make some changes, find out what's going on. You know, put the mix down that's in front of us. You know, we don't want to leave it there and let it get cold, but we definitely need to stop and pick it up and look and see what's going on. And when we do, we basically find out that the screw plates wore out. You got bird baths across the string. You got gaps and holes, and it's not making consistent contact pressure. You know, you got bent floor pan extensions. Maybe happened whenever they were mobilizing this machine, when they were moving it from one project to another. The floor pan extensions got bent, which helps with material management. And Will may have talked about this in his presentation prior to mine, but if you don't have those, then coarse aggregate is going to roll and it's going to segregate, and you can have texture issues like you've seen in the previous photo. So if we had got up under the paver before we started that day, we would have seen all that without having to put a string line, straight edge, or any other kind of tool on it. So checking it every day is a very proactive approach. You know, a 15-minute spot check can save $15,000 of downtime or $15,000 of rework. So we look at this mat right here and we say, what's wrong with it? And I don't know, I can't tell you anything that's right with it. So I guess we would say everything is wrong. Somebody didn't check the plates, and you can see here that the extension plates on that extendable are slap wore out. So we know that nobody has been checking or watching or making any necessary changes. And when it gets to this point, it will not pave. There's nothing that can be done to make this screed or make this paver work in this kind of condition. So at this point, this is when you'd want to stop, put it in the shop, bring another machine out. So we look at this mat, and it's not terrible. And we do see some little pulling, some dragging. And this is, of course, directly behind the screed before it's been rolled out. See a few little shadows here and there. We look over at the inboard ski. It's probably still a little bit cool. Maybe we need to heat it up some. Put a little releasing agent on top, clean it up a little bit. But the little stripes that you see between the two inboard skis is something that needs to be addressed. I wouldn't say it's bad enough to stop and pick it up at that point in time, but it's bad enough to make sure something's done about it before we start the next day, or we get to the end of a pool and we've got to turn around and come back. We need to get up under it and check it out. And when we do, and this is primarily what we find more than anything else on any of our machines when we're having issues, is a strike off issue. So the strike off is a little different, the height of it, you know, different manufacturers' machines, but as a rule of thumb for us, no matter what the manufacturer says, we always keep it about a ½ inch above the nose of the plate. Some of the extendable screeds, the strike off is actually a little bit lower, but that's primarily because they ride at a different angle than a wedge lock or a wider screed would, a wider screed plate would. So, you know, if we just had stuck our head up under the paver, we didn't even have to touch it, just got down on one knee and looked, you could see that the strike off's too low. And when the strike off's that low, coarse material, coarse aggregate just rolls in front of it and it will not pass up under the screed. So it starts pulling and tearing. Even though that's not detrimental and the air voids are probably okay, we should not be paving like this. We should stop when we get opportunity to and fix it, pull it up. So this is something that we do every day with Reeves, and it's evolved over about 10 or 15 years, and we're actually electronic now. We did have something called FormStack that we used, and now we have a program called Darcy, which is like an inspection program, QR codes and whatnot for each piece of equipment. And we log it, and we do KPIs every month and measure how many checklists were done, what were the common problems on the checklist that were identified, not just operational, but safety too. It's been a great program for our business, and it's constantly evolving, and we're getting good things out of it every time it does. So the crews wasn't very receptive to it when we first put it out, the checklist, but everything is electronic now. They can do it on their iPhone, their iPad, the computers. It's real simple. They actually like doing them now because it actually more than anything else helps us with accountability. So it's not always the foreman's fault or the crew's fault. You know, it could be what they've been given. So accountability is been a great benefit from this. So we did not check the screed that morning. Don't know what happened. Generator might have started acting up, but we've got a cold screed. The main screed's cold. The extensions are hot. You cannot pave with a cold screed. So the only thing we can do right here is just stop, get another machine out, or either get the mechanic out to figure out what's going on. But you know, we don't need to continue paving like this. And to a certain extent, I've heard people say that it'll warm up, but you know, it'll never, the mix will never flow up under the screed the same if it doesn't have self-heating, I guess. So we should have known that we had issues before we started that morning. So this is a problem that can happen, and it will happen. And as long as we're working and we're putting down asphalt, it'll always happen. It's just how do we react? How do we respond when it does? But this is a double screeding issue, which is basically a volume issue, volume inconsistencies, which volume equals density. So there can be some drastic density of variability whenever you see double screeding like this. When you've got a extendable screed, when you've got multiple plates striking the mix off. So this is a photo showing the variability and the density across the mat. So in the areas that are real slick and tight, you can see that you've got to your right hand side there 143 pounds, and in the center you've got 135 pounds, and on the outside 137. So you got multiple plates passing in the quarter points, reducing volume each time. And then in the center, you've got the main plate, and the outside edges, you've only got the extendable plate. So you've got to have all those plates balanced. You got to have a consistent volume. In the end, whatever it takes, whether it's an angle of attack adjustment or whether it's a vertical height adjustment, it needs to be balanced out where you can get consistent pre-compaction or consistent volume from joint to joint. This is another example. You can see the double screeded areas, and you can see how the density is lower in the center. This is unacceptable. This is one of those situations where you don't have to worry about scratching your head and saying, huh, should I or should I not? You know, this is what we would call unquestionably unacceptable. And we ought to just cut it off right here and not continue, no matter how much mix or how many loads we've got sitting in front of the paver. Because it's a lot easier to send it back and put it on the pile than it is to come back and mill it and take it all back up later. Better to do it at this point than it is when the project's complete and the ride's done, and we're trying to get it sold to the customer. So again, those places that you just saw before, once it's rolled down at this point, there's really nothing you can do besides rework. There's a lot of pulling and tearing, but there, main strike off a little bit low. Some of that can be cosmetic, but the only true way to find out is to actually go in and cut a core. Section 400 gives guidance on questionable mix, what to do. 13.5%. I think that's right. 13. So it's 1% AC, 10% gradation, and I think 13% air voids. So when the core is cut and it exceeds any of those, then it's considered unacceptable and has to be removed and replaced. So so there's stages, there's steps, there's guidelines to determine what is and what isn't acceptable. Nobody can really look at asphalt, can look at a pavement, because everybody sees things differently. So, you know, visually acceptable or visually unacceptable is not really acceptable. So, you know, if you're gonna be taking something up or asking a contractor to do rework, or a contractor asking themselves, do I need to do rework? Cut a core. That'll tell you, that'll guide you. You know, well, never lied to me. It might lie to you, but it's the best method. So this is what acceptable looks like. Your consistent texture from one side to the other. whether it's consistently open or consistently closed, consistently rich, consistently dull, consistently pretty, consistently ugly. The key is consistency from one side to the other. So it could be the ugliest thing you've ever seen, but as long as it's consistently ugly, that's okay. So we talk about from joint to joint being consistent. So you see consistent texture all the way across, odds are you've got consistent density, you've got consistent temperature. You're going to have a good ride. It's going to be a good day. So some things that would affect visual streaks and inconsistencies in texture, we battle them all the time. Most of the time they're mill and inlay jobs where we didn't mill deep enough and we've got a lot of scabbing, or we didn't have enough leveling, scope of work in the contract. So, we might have needed 100 pounds of leveling to get the ruts completely out and the quarter crown out to make it flat from center line to shoulder to ensure we have positive drainage. But we didn't have enough. We only had 50 pounds. So the road's pulling and tearing in the center. And if you come in and the quarter crown is still there and you top it, then of course you're going to have, the mat's going to be thinner in the center than it is on the sides. So, the mat is going to be reflective of what's up under it to a certain extent. So that's something, that I think good relationships foster is in communication. Is this is what we got. We know if we put the product on top of this is what you're going to get. It's just going to meet your expectations. Going out and looking at the road together, not just pulling up Google Earth and looking at an image, but actually getting in a vehicle and going out to the job and putting a straight edge on the road or a string line on the road and talking about the issues before the work starts is the only true way to do business and be successful and mitigate the risk for the contractor or mitigate the risk for the DOT. Communication, you got to have it. You got to get together. You got to put boots on the ground, identify any kind of challenging areas and come up with the best solution that we can based on the funding that we have. And of course the delivery date for that job. So we've got a problem here. Some of you that have been in the business long enough probably 100% jumped on it as soon as you saw it, but you can tell that's OGFC on the interstate project, and then it goes into something very fine, like a fine dense graded mix, and that's basically transition trying to run a specialty mix and a dense graded mix at the same time in one silo back and forth, and not transitioning enough waste or not transitioning out of one long enough before you went to the other. So of course this had to be repaired. I guess what this is trying to say is anytime you're running a specialty mix, whether it be SMA or OGFC, you have to dedicate that plant to that mix on that project and not try to run multiple projects at the same time. So if you don't know, you don't know. And I don't know, been in this business for a while. Yes, seen a lot of asphalt, seen a lot of good stuff, seen a lot of bad stuff. But I learn something new every day, and I see things that I've never seen before all the time. There's always better ways. There's always new ways. There's always ways to use some of the old and some of the new. But if you don't know, call somebody. The worst thing in the world anybody could do is not speak up, not say something. And if you're an inspector and you see something that concerns you, then go to the paving foreman, go to the project manager, go to the project engineer, say something. If you don't say anything, and you're walking and you're looking, that insinuates that everything's okay. So brief conversation, picking up the phone, calling somebody, just effective communication is the only way to build a project, and that applies to a lot of things, not just pavements. So we got up under the screed. After we saw this, we stopped, we picked up mechanics on the way, and we found that the screed's all jacked up. The extension plates are out of whack. The strike off is blowed out, a little bend in it. The mini strike off shoes on the front of the extension plates are torn or warped. So we're not going to be able to pave with this machine anymore today. So we've got to make some changes. So a lot of times, people have thrown back on the mat after it's been rolled. and they call that sanding out the blemished areas, whatever that blemish might be. And this happens to be cold mix with footprints. Somebody let the cows out of the pen and they came across the mat, but you cannot go back and try to sand this in and roll it and try to get that out. The only thing we can do at this point right here is just take it up and fix it. You can sand it out before it's been rolled when it's still hot, or if you've got a heater, that you can take back out and warm it back up. But in my time with GDOT, and as far as I know now, that hadn't been an acceptable method of repair for most jobs and most people. But indirect heat could probably take care of this, but it shouldn't have been done this way. It should have been fixed before it was rolled. So one of the biggest things that we're seeing now is a lot of it is to do with how the contracts are set up and the scope of work versus the needs of the road. Certain mixes can be placed at certain thicknesses, and it's all based on the NMAX, we call it, the nominal max size aggregate, and then how many times the aggregate size will be your thickness. So 3 to 4 times the NMAX is typically the sweet spot for the mix type. So 25 millimeter mix, base mix, if you try to place it 1 inch thick because it's got number 5 stones in it, it's going to ravel, it's going to pull, it's going to drag. It's the wrong mix to be placed at 1 inch thick. We've had a lot of contracts in the past where it was set up with a 9.5 type 1 mix at 90 pounds. Even though 9.5 type 1 can be placed 7/8 of an inch or roughly 90 pounds by spec, you might not necessarily be able to place it because you're running off a spread rate, and a spread rate isn't always going to be perfectly 7/8 of an inch. So if you run into something where you got a 1/2 inch here and 1.5 inches there, that place that's a 1/2 inch thick is probably going to look bad. It's not going to get density. It's going to cool really fast. If you're going to put down mix that thin, a 4.75 probably would have been the right choice for it. So just knowing the road needs, knowing your mixes is very important, especially when you're setting a job up. And if we as contractors do see something in the job that we know we can't do, we talk about it in the pre-con. Say, hey, this mix might be better, and we reference GDOT specifications, and we typically work through it. But it's a lot easier to work through the problem, before the work starts. It always is. So section 400, if you've never seen this table, it actually gives you guidance on the mix type versus the min and max layer thickness based on the NMAX, the nominal max size aggregate. So this actually is tying down on a job. The mix 12.5. There wasn't any other mixes in the pay items to tie down with. I'm a mill in butt joint kind of guy. We don't like to tie down and pull like this because it typically does ravel back. But if you have to do this, then the best thing is use a load of 9.5 to tie in with or tie down with. If you try to pull 12.5 down to nothing like this, it's going to start raveling out probably about the 1 inch thick mark, especially when aggregate starts breaking, when the rollers hit it. Just doesn't work. So, having a plan, knowing what you're dealing with, knowing what mix to use for tie downs, knowing what mix to use for leveling, for patching, very important before the work starts. So GDOT has got a specification that basically says that you cannot use different aggregate sources on the surface mix only because of color variability. So, some aggregates have got reds, tints of green, tints of orange. Some are really dark gray. Some are really light gray. Some are a white looking color. Some are aggregates are much darker and lighter. And once the asphalt, the film has wore off the aggregate from traffic, then the color of the aggregate dictates what the road looks like. So GDOT does not allow that. The only time it can be done to swap aggregate sources on surface mix is when you've got something breaking transversely, like a set of railroad tracks, a bridge, or whatnot. But this is the reason why GDOT requires the surface mix to be from one source because it's cosmetic, not quality, but more so cosmetics. So base prep for new hot mix asphalt pavement, very important. Roads built from the bottom up. I mean, if you've got something pumping, something moving, something weak beneath, we hear, we'll put enough thickness on top of it, we'll bridge that problem. That not necessarily going to happen. You might bridge it for a little while, you might get by with it for a little while, but sooner or later it's going to come back, and you end up wasting a lot of money in the beginning or the end if the base isn't stable. We have seen some pretty horrific stuff in the past, especially whenever you have an inconsistent section. So your travel lane might have a lot more structure than your shoulders do. Maybe your travel lane is built in a box we call it a bathtub, where it's a non-full depth section on the shoulder. You've got a clay type subgrade up under the shoulder, encasing the GAB under the main line. The granular base can't drain. The water can't get out of the road. And again, roads, the key to a successful road is drainage, 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 and more drainage and drainage again. And that starts on subsurface. But surface is very important too. But subsurface, if you don't have positive subsurface drainage, then it doesn't really matter what you do from the bottom up. Trapping water, with the bathtub design has been a problem for 20 or so years. The department saves a little bit of money because of materials, but in the end, it ends up costing more, we think, with labor and time and whatnot, because it's actually two separate operations. So if it's moving, if it's pumping, then we don't need to be paving on it. So this is what happens when water gets trapped up under asphalt. When there's too much moisture, whether it be water vapor, whether it be just got rained on the night before, and we put something that's impermeable on top of it, it's going to move, it's going to slip. You only got one option at this time. There's no way you can back up and take a mulligan on this. You got to take it out and fix it and do it again. So anybody have any questions, anything you'd like to ask me before we move on to the next presentation?
Sure. We got one question. What's the next big thing in asphalt? Sort of a broad question, but.
Okay, so for me, the next big thing that being involved with Napa, Colas, which is the company that owns Reeves, working with different DOTs, just basically right now, the biggest thing is balanced mix design and trying to figure out what DOTs are going to do with it, how they're going to implement it. Is it even reasonable? Will it help us? Will it not help us? But balanced mix design is basically trying to find a balance between rutting and cracking. And everybody's got a different approach to it. Some states are only going to use it in a design phase, which is basically what GDOT's using right now. And some states, I think, are trying to implement it in the acceptance stage. And they're having a lot of problems with it because the test takes so long, the sample prep takes so long, and you can have a bunch of tons on the ground before you really know what you've got. So GDOT's taking the approach, South Carolina DOT, North Carolina DOT, all the DOTs that I work in primarily are taking the approach to do a balanced mix design and leave it in the design process and just continually test for AC and gradation like GDOT does. So there's still a lot of things up in the air with that. I think that the rutting test, which is the Hamburg, which is what GDOT uses right now, is pretty predictable, it's pretty reliable, it's pretty repeatable. But people are using different test methods for cracking susceptibility, like the SCB, which does the ideal, the iFit, does several other cracking tests. But GDOT is looking and basically trying to benchmark all their mixes using the ideal CT, which is probably the friendliest test out there and the most practical test out there. And I don't really know, that would probably be more of a Josh question where they are, or Jason question where they are with it. But right now, as far as I know, they're just benchmarking to see what number is even possible based on the mixes that we have in place and based on the performance that they're seeing and the success and the service they're seeing with it. And then EPDs are big, and environmental product declarations. FHWA is really on it. I think we're going to hear a lot more about it, and it's all about reducing carbon footprint, going green. More wrap, more warm mix. Less materials that you have to haul long distances, which generate more carbon. I don't really know exactly yet how it's going to pan out, but there might be some handcuffs, I guess, or might be handcuffs some in the future by the FHWA with some of the EPD requirements, having a product declaration for a plant and different mixes. But recycled products are definitely going to play a huge part of the asphalt industry, the future of the asphalt industry. It's going to have to go greener, which that should be our focus if we're good stewards of the planet, always trying to find a way to make it greener, reduce our carbon footprint, just do our part as the industry. But I hope mandates don't come, because GDOT, the contractors, nobody likes mandates. Mandates are never good for anybody. And I think based on what I know about the EPDs right now, is NAPA. It's actually through NAPA, but it's the FHWA and NAPA. They're basically benchmarking again, just trying to see what is possible based on what the type plants, the type mixes, the different markets that different contractors operate in. So it'd be a good read if you pulled it up and took some time. But there's a lot of good things are going to come out of it. But our worst fear is being handcuffed again and having to deal with mandates, which is never good for anybody's business.
We got another question kind of along the same lines. Has cold mix asphalt gone away?
Cold mix for patching? Is that what you're referring to?
Did not specify.
Well, cold mix will always have a place as long as we've got potholes. And if we've got pavements, we'll always have potholes. So hopefully we won't have to buy as much, or people won't have to buy as much cold mix for patching, because the quality of the asphalt's hopefully going to get better and we won't have as many potholes.
He answered, or you answered his question.
Okay.
Very good. We have another question in, if you'd like to address it while you're setting up. What is the maximum multiple for pavement thickness based on aggregate size?
Well, there's different approaches to that, but if you think about what GDOT does with a 12.5, so a 12.5 millimeter mix, that's a ½ inch. So they put it down primarily in all their jobs 1.5 inches. So 3 to 4 times. I'm more of a 4-time kind of guy, and so South Carolina DOT would put a 12.5 mix down roughly 200 pounds or 2 inches, where GDOT will put a 12.5 mix down at 1.5 inches. Thicker's better when it comes to what we're about to talk about on joints and different things. But as far as density goes and performance goes, it's not that big of a difference. But yeah, 9.5, 1.5 inches to me is better than an 1.25 inches. 19 millimeter, 3 inches is better than 2. 25 millimeter, 4 inches is better than 3. It's easier to place, easier to compact. And I know GDOT has been talking for a long time about changing some of their mix selection guidelines and maybe the thicknesses. And I think they constantly review that every year to try to see where they need to be to improve things like joint density, joint construction. So I'm sure there's something going on right now, some kind of discussions, and they're always thinking about ways to improve. And I know that's been a topic for 10 or 15 years. Because I was part of several of those discussions in the past. But a lot of it goes back to funding. But yes, I would rather see 1.5 inches, a 9.5 type 2 than I would 1.5 inches, 12.5. And we've learned a lot how mixes will perform. With all the performance testing that we didn't have years ago before the Hamburg. All we had was stability and flow with Marshall. We didn't have rutting, cracking, and all the new technologies that we have now. So I expect there to be some changes in the future. And if we're not changing, we're not growing, we're not developing, we're not getting better. So there's always going to be change. Even though the older I get, I struggle with change. But you got to have it, So yes, I think there'll be some changes in mixed thicknesses based on max nominal in the future.
Got one more question. What about a spread rate of 55 pounds on 1/2 inch, 4.75 millimeter mix?
There shouldn't be a 4.75 millimeter mix at a 1/2 inch. Or are you talking about a 1/2 inch thick? 55 pounds on 4.75? Yeah, I mean, it's been used for leveling for years and years. Just according to how bad the road is. I mean, that's part of going out and doing a pavement evaluation, if you want to call it, before you start the work or before the project is put out, before you really know what kind of quantities you need, right? So, I mean, we go out there and we lay a string line or straight edge down and we see that we got a 1/2 inch quarter crown with 1/2 inch ruts. 55 pounds of 4.75 is not going to be enough. Now, if the road is pretty flat, you might get by with it. But I would say if there's any more than a 1/4 inch of any type of irregularity, 55 pounds is only going to drag the low or drag the high spots and fill the low spots, which probably not going to be enough to help improve drainage and structure and ensure you've got good density all the way across. Hope that answered your question. Move on. Okay, so we'll move on to the next presentation. And before I start off talking about joints and pavement irregularities, profile and irregularities, I want to say again, repeat what I said earlier about drainage, 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 and more drainage. You know, got to have positive drainage. And going out to the job before the work begins to see what the condition the road's in dictates what you need to ensure you've got positive surface drainage. And this is primarily what we're going to talk about here with joints and pavement irregularities and profiles. But subsurface and surface drainage are two of the most important parts of any kind of pavement construction, concrete or asphalt. So there's two basic types of joints that we deal with in our business. That's longitudinal and transverse. You know, joint, of course, is a weak point in asphalt. We don't want water to get into the pavement. We don't want the pavement to be permeable. You know, and a joint is the weakest part of the job of the pavement. You know, it's just according if water's crossing a joint or not, and how much it can influence. You know, how long or what kind of service problems we may have because of joint problems. So, you know, the simplest way to fix a joint problem is to not have one. You know, but for the most part, we don't have that luxury because the way we have to build roads. You know, most of the time we've got traffic on one side and we're paving on the other. So it's hard to eliminate a longitudinal joint. You know, unless you're at an airport, if you're pulling parking with the travel lane at one time, you might think about hot lapping or doing extremely wide pulls if the project allows, if the scope of work allows. But eliminating the longitudinal joint, I don't think for the type of work that we do, and we have to keep the traveling public moving. We can't shut jobs down. They're always going to be there. Of course, if there is opportunity, like at an airport or a new construction section where you don't have to worry about traffic staging, you know, pave wider. Use 2 pavers if you can. Hot lap. So this is an example of hot lapping. If you did not know what it was, it's basically when 2 pavers follow each other, or one paver makes a pull, backs back up and makes another pull. A hot lap is, to be a true hot lap, the roller cannot have hit the side that you're lapping. It has to be rolled in together. So if the first pull that you're making, if the roller rolls it all the way across and then you try to tie into it, that's not a true hot lap. Can't be touched by the roller before it's rolled down. So rolling a longitudinal joint, again, because of the type restrictions that we have with the way that we do work, maintaining traffic, you know, there's really only one way to a certain extent. The most efficient way to main traffic and get a good joint is rolling from the hot to the cold side and overlapping the cold side about 6 inches. You know, if it were a new construction project or if it were a job where we didn't have to worry about traffic, a good pinch, the first pass, pinching from the cold to the hot, pinching that hot material in works very well. But we don't have that luxury most of the time, and everything's got to be rolled from the hot to the cold. So a couple challenges constructing longitudinal joint that'll never go away as long as we've got joints is proper overlap. And most of the time that comes with steering a straight line. And a lot of times steering a straight line comes from what kind of paver you're using, whether you're using a rubber tire machine or whether you're using a track machine. Our operators struggle with a track machine more than they do a rubber tire machine. A rubber tire machine is much easier to keep straight than a track. But it does dictate what kind of overlap you're going to get, and that dictates what kind of joints you're going to get. So we don't want any more than a slight taper. We want to try to keep what we're tying into as vertical as we possibly can. And the end gate, the condition of the end gate on the paver actually dictates how vertical of a joint you can make. So low density areas, that's what we want to prevent at the joint. You know, keeping the gate in good condition and making sure that the head of material is consistent and the material being forced out to the gate is consistent is very important as far as joint density and keeping a vertical edge. So cold surface for bonding, sufficient material. So I'd say overlap and sufficient material are the two most important, with sufficient material probably being the most or the primary reason why you do or don't get good joint density or get a good longitudinal joint. So, you know, you're tying into something that's already been rolled down, volume has been reduced, density has been increased. You're placing something, joining it, you know, that's only got about 80% compaction from the screed. So you're going to get your 1/4 per inch of roll down. So you've got to predict, you know, how high you need to be above the cold. And I see it all the time. Our guys do it. It's just something that's always going to happen. You don't have enough material up above the cold, and it might roll down and look okay, but the roller might be bridging over, or it might cause a little invert because there wasn't enough volume of material there to match the cold joint. So that's something very important, and that's something that I like to look at every time I'm out on the job. Segregated material at the joint. Most of the time, if you've got that, it's because your end gate is worn out, or your auger speed is not consistent, not running 90% of the time. You don't have it confined and coarse aggregate rolls and segregates at a paver just like it does in a silo, or separate, segregate, coarse aggregate roll down. So this is the end gate. If you didn't know what it was, all pavers have to have them. They don't need to be bent. They don't need to be twisted. They need to be functional. So you can keep that joint as near vertical as possible. And keeping the head of material where your augers are, like Will discussed, keeping it moving all the time. Make sure that the force of material out towards your end gate is consistent. So at this point right here, this has a lot to do with what kind of joint you're going to end up with. So why do we stagger paving joints? If we're not, we should be. Because as we talked about earlier, longitudinal joint is a path for water to get in. So you don't want that joint all the way down to your base to allow the water, a door, to get down to your base and soften it up and lose stability of your granular base or your subgrade material. So GDOT basically says stagger 12 inches between lifts. And one of the biggest things here is putting thought into it before we start the work, and making sure that we start out right so we can end up right. If you look at this picture, I've seen it before. We put our base mix down on top of our granular, our base asphalt on top of our GABC or a soil cement or whatever we're using, and it would be not the same width as the surface. So basically, you got your base, your binder, and your topping. Good rule of thumb is whatever you're going to pull your topping at, that's what the base needs to be, and the binder needs to be, or the 19 millimeter needs to be staggered beneath it. But a lot of things to consider when you're putting a plan together is will it be pulled with a travel lane, basically the shoulder? What kind of traffic staging you're dealing with, and is it the same cross slope? So you know, you always want to balance the screed if you can. But most of the time, if you're pulling the shoulder with the travel lane, the shoulder's going to be at a different slope on the outside. Inside 2-foot shoulder, most of the time is going to be a 2%. But you know, 99% of the time, the outside is going to have a 4 or 6% on the shoulder, whereas the travel lane will be 2. So you couldn't sit down and pull a balanced 16-foot or a balanced 18-foot. So you'd have to extend out and put auger extensions and whatnot. But one thing I always consider is where the joint's going to fall before you make that decision on how you're going to build the road. So when this happens, you see the joint in the wheel path. That's not acceptable. Traffic will beat that joint out. It'll start raveling. Might not be this year. It might not be next year, but it'll eventually prematurely fail. And the specifications actually require that the joint be up under the lane line or as close to the lane lines as they possibly can. The only time that a joint should be stacked and not staggered, when possible, is when you're putting OGFC on the interstate. It's stacked on top of the SMA or whatever mix is directly up under it. So the joint is usually the first location for failure to begin. You see here that there's some water issues beneath the road, and that water is coming up at the joint. So water, when it gets pressure on it, head pressure, it's going to find the weakest point to come out, whether it's the lowest density area in the mat or a joint. But it will travel between layers, and it will travel through base, and it will come up in the weakest place, which is always a joint. And a lot of new construction projects where we've got a non-full depth shoulder or doesn't have a consistent typical all the way across, a year or two after the job is built, or even while the job is being built, you'll see water coming up at the main line joint to shoulder interface, and that's because of the path all the way down where it was built, and then you got moisture in the GAB up under the main line that can't get out of the road, so it comes up through the joint, which is the weakest place. So we would probably not consider this an acceptable joint. This is naturally it looks like a base mix to me, 25 millimeter, but it's going to be covered up with binder and topping. But we wouldn't want to see this. We want to make some changes. We want to start looking at how we've got our paver set up, how we're making the pulls, what we're doing here, sufficient material roll down. We definitely need to be looking at something, not continually paved this way. So a lot of times, you can come back if you do have a problem and fix it and work it out. But coming back and this looks like they came back with some fine mix and tried to shovel it in the joint and tried to roll it in. I think that's what that is, or it could be. I don't think it's crack sealant, but again, going back to what we talked about in the previous slides, you can't go back after it's been rolled and throw a little mix in the hole and roll it in. It won't last. It'll ravel back out when traffic crosses it. So this is not a solution. So is this an acceptable joint, and what challenges will this present? So first of all, the mat is not acceptable. So my eyes didn't even jump on the joint here, but the joint is crooked. You can see it's not straight. There's kind of like a little dog leg there where they started out. It looks like where they tried to tie in and start up the next day. So when they come back and tie into that joint, they're going to have to run the extension out, or either they're going to have to move the paver. But out of the way, the extension is probably going to be ran in and out to try to match that joint. And every time the extension is moved in or out, the head of material changes. Hey, Jacob, something popped up here about Bentley connection issues. Am I still on? Okay. Okay. So it doesn't mean anything? Okay. That's all right. It's not my way. So this is what happens when you don't pull a straight line. It makes it very difficult to tie back into. It's probably going to impact ride. It's going to impact texture, because every time we run the extension in and out, we're probably going to pull and tear and drag just a little bit. Thank God this was leveling, and this is surface treatment with leveling on top of it. And this is something that we see a lot of, which is not good, but it's not bad because it is leveling. But with surface treatment, interlayer, most of the time if you're using a rubber tire machine, it's going to spin in the rock and the emulsion, and it's going to cause the screed to move back and forth, or the whole machine to walk back and forth. So This kind of construction, when you're putting down surface treatment as an interlayer with leveling on top of it the same day, you know, using a buggy, separating the truck into paver, or either having a track machine is critical. All right, Jacob, what we got here? Here it is. Okay, we got it. So, is this an acceptable joint? What problems do you see? So again, I believe this is a leveling course, but you can see the segregated material. You can see the crack there. We can't tie into this. This would have to be cut. It'd have to be repaired before we tie it into it. We could probably broom it aggressively and get rid of some of the loose segregated coarse material. But if this is a surface final layer, we need to make some changes here before we cover it up. So what will happen if the next lift of asphalt is placed over this defective joint? So this looks like 25 millimeter, and one lane is actually higher than the other, maybe like an inch higher. So we're going to put 19 millimeter on top of this, and we're going to have to stagger it 12 inches. So if we're putting 2 inches of 19 millimeter on top of this, then whatever overlaps from the right to the left when we stagger the joint is only going to be 1 inch thick. If it's a 1 inch irregularity, and we're putting the mix down 2 inches. So this joint is not only not just an issue as far as the base material goes, but it also can impact what's being put on top of it. So, you know, it's got to think about what the next step is, not just today, but we've got to think about tomorrow. And will this work? Or we're going to be able to put pavement on top of it that we're going to be able to meet density and ride that's going to provide the service that we need. So when you see a nice straight joint, that's what we want. Easy to tie into, easy to roll, very consistent. It'll last. So segregation at the joint, most of the time is when a loop man might get a little happy. You know, any time that the loop or shovel touches the mat, it's going to leave a shadow. Not necessarily a detrimental shadow, but it's going to leave a shadow that some people might think is going to impact serviceability or density. But this is most likely where the loop guy pushed back on it and didn't rake the course off. And it's just on the surface, probably more cosmetic, but the only way to find out how bad it is again is to cut a core. So transverse joints. Transverse joints are also a necessity in our business. There's very few jobs that we construct where we can sit down on one end and pave to the other end and turn around and come back. So pretty much every job that we do, or at least that we build for the DOT, there's got to be a start and stop. And the way we do that is a transverse joint. So we want to make sure that it's cut vertical. We want to make sure that it's cleaned. We want to make sure it's tacked, and we want to make sure it's straight edged before we take off and tie into it the next day. Most of the time, if traffic is exposed to the construction that we're in, we've got to build some kind of ramp, temporary ramp. We can't just have a vertical drop when traffic runs off of it. We've either got to use a paper joint, or either we've got to taper the mix down and saw cut it the next day. So whichever works. The main thing is that we start where we stopped, or that we stop where we start. Yeah, start where we stop. So wherever we start at the next day, whatever the mat elevation is, that's where we're going to start. And if you don't start right, you're not going to end right. And if you don't end right, you're not going to start right. So that's a tongue twister, isn't it? So if you don't have a good place to start, because the paver fell off, or because we cut the augers off and the screed tapered down, then we need to back up 5 foot. We need to back up 10 foot. We need to back up 20 foot, saw cut it, and start at the elevation or the mat thickness that we need to be or want to be. So this is not, I would say, a good paper joint. And the reason it's not a good paper joint, not because of the paper joint part, but they should have backed up probably a couple feet and shoveled that out vertical so they would have a consistent width of the mat. So you can see on that bottom side where they look like they might be a foot off, and that's going to have to be taken care of the next day. So it's a lot easier to cut it out, shovel it out, drag it back, when it's hot than it is when it's cool. So you gotta basically saw cut now. You could have just took and took the loader and pinched it off if we had done it right when it was hot that same day. So chiseling or saw cutting to get a vertical joint is yeah, that's okay. I like saws. I like cutting. Having a saw on a job, you got to have one because you're going to run into issues where it's going to have to be saw cut or it's going to have to be touched up. It's got to be clean. It's got to be tacked, and it's got to be ready before we sit down and tie into it and pull off. You know, most of the time, the joint problems that we experience is because our paving crews got in a hurry and the paver pulled away from the joint and didn't give the loop guys time to really do what they needed to do. The paver got a half mile down the road and they needed 2 shovelfuls of asphalt to get the joint where it truly needed to be. And that's a long walk carrying a shovelful of asphalt. So they just kind of make it as good as they can get it. So, you know, we try to pull off the joint 30, 40 feet, stop and wait and give the guys time to get the joint right before we pull off and get away from them. You know, it's all hands on deck until it's straight edged and we know it's good before we leave. So a good loop man is very important, and the loop's got 2 sides. One side's for raking and one side's for pushing, and sometimes I think people forget about that. But it's very important that if we are moving the joint around, if we're bumping it, if we're throwing mix back to get the elevation right on the tie-in, that we turn it over and pull out the coarse rock with the rake side. If not, then you can have a segregated joint that might ravel out when traffic's put on it. But before it's rolled, again, once it's rolled, you're pretty much locked in. There's not a whole lot you can do. It needs to be immediately straight edged before the roller touches it, whether you're cross rolling or whether you're rolling it longitudinally. Got to have the straight edge on it. And then after every pass, straight edge it. And all that should happen before the paver gets too far away. So here is a segregated joint that construction traffic is raveling out, which appears to be base mix, which is hard to make a joint with anyway. But it doesn't look like the loop man actually raked the coarse material out and he just bumped it back in and started raveling out. So turning the rake over, raking the coarse stuff out, and then bumping it back in and bumping it up tight before it's rolled is the only way to get a good joint. So, you know, it's something that you got to take time with. You can't get in a hurry. And that's something that should be planned for the amount of time every day that it does take to get the joint right before we proceed with the paving. So constructing transverse joints with specialty mixes, meaning SMA and OGFC, it's basically one and done. You don't have a whole lot of opportunity to touch it with a shovel or a rake. And if you've ever put a rake or a shovel in SMA or OGFC, you know what I mean. It's very sticky, very stiff. It limits the amount of handwork that you can use. So you kind of got to get it right the first time. Whenever you pull off, you got to be right. You don't have a whole lot of opportunity, and there's not a lot you can do. And the more you touch it, the worse it looks. So rolling the transverse joint, of course, cross rolling is always the best approach if it's possible, if the work will allow. Most of the time it doesn't because we've got traffic running in the adjacent lane. But if it does allow, and you've got some boards, it's always best to make a pass or two in static mode and cross roll it. But if not, typically what we do on all our jobs, again, because of the limitations we have because of maintaining traffic and the type of work that we're doing, is rolling it longitudinal, crossing over from the cold to the hot. And the main thing we do here that we always need to recognize is that we do not need to turn the vibe on until that drum gets on the hot side, because the vibratory roller will fracture aggregate on the cold side. So a 10-foot straight edge should be available. 12-foot straight edge is better than a 10-foot. The longer it is, the better it is. The joint should be checked before we proceed paving that day. After it's been looted, after it's been left, after it's been rolled. You know, punch lists are bad. We don't like punch lists. So it's always better to take care of it while you're there, not leave it and say, well, I'll get to it on the punch list, because we don't want a punch list. We want to have to come back. You know, contractors want to get in and do the work, get paid for the work, deliver the work, and move on to the next job. And rework's never good for anybody. It's never good for the contractor. It's never good for the customer. So handling it that day at that time, or while you've got your resources and equipment in that area, is always the best way. So this coming off a bridge, tying into a bridge deck, didn't tie in very well. And this is a looks like a 4-lane job where water's got to cross the joint to get off the road from the inside to the outside. And of course, this had to be fixed. Should have been fixed that day, or it should have not happened that day, or it should have been checked the day it was paved. But there's definitely, when it came off the deck, it fell. Shouldn't leave this kind of stuff. We shouldn't say, well, hey, we'll come back and take care of it. You know, we've got an opportunity right now to do it. We've got everything we need right now. So temporary ramps at bridges. I've seen a lot of this happen before, where somebody would say, well, that wasn't my job. I'm just a paving guy. I'm not supposed to take these temporary ramps out. But asphalt does not stay when it's pulled thin. And I think we talked about that in the past presentations with the type mix and the thickness that type mix is placed. But you know, you can pull it over it, and you might get by for a day or two, but in time it's going to ravel back until it gets to the thickness that best suits that end mass, that mass size aggregate. And this right here was just basically leaving a temporary ramp in and not taking it out to get the vertical tie in to the paving rest there on the deck. Naturally, it had to be taken out and repaired. 8-foot shoulder pulled separately from the travel lane. You can see that they put it in, and there's a big windrow there on the left-hand side where the material overlapped in the travel lane. They might have took a motor grader and pushed it back in, because most contractors don't have 8-foot pavers. We do have a few, but the majority of the machines that we have are 10-foot. So you're always going to either have to run a cutoff shoe, or you're either going to have to overlap and kick that material back in, or pick that material up and take it off. But in this situation, it appears that they decided to push it back in, which made a large volume of material that couldn't be rolled down, that would be causing the water not to get off the shoulder. So that had to be taken up. Not positive drainage right here. The water was backing up into the main line, and I'm sure when it's raining and you get some of those South Georgia frog stranglers that we get every now and then, it would push back into the wheel path, which becomes a safety issue. So, you know, the joint here, bad tie-ins, not checking it before you left. Bolt-on extension may have been misaligned, but this shouldn't have happened. Should have stopped. Should have made some adjustments. So again, roads are built from the bottom up. Profile and grade are very important. You know, naturally, what you do below is going to directly affect what you do on the top. So the performance of the bottom is going to impact what happens on the top. So here we had some errors. We're looking for a 2% cross slope across both lanes, lane 1 and lane 2, towards the outside. You can see that the outside lane might be a little flatter than the inside. We might have 1.5% on the outside. We might have 2% on the inside, but there was too much overlap on the joint. Water's not going to get off the road. We're not going to have positive drainage, and there will be failure here at some point. And I know exactly where this picture was taken, because I took it and I watched it for a long time, and it did fail. The joint started raveling out at this point. It took about 15 years, but it did eventually ravel out. So here you can see pulling a string line across both lanes, and there's positive drainage in lane 1 and lane 2, but there's a sag, which means when there's a sag, the water is slowing down when it crosses the joint, especially, you know, when there's not a crown point there. It gives it time to penetrate and gives it time to get into the joint, which in time turned into the water traveling between layers, between the surface mix and the intermediate mix on this exact picture, because I took this picture too. It slipped, it laminated, all because water got in the joint and started traveling between the 12.5 and the 19 millimeter. Positive drainage, that's the key. Always positive drainage. That should be everybody's first thought when they start working or putting a job together. So this is also an example of water crossing a joint. So the one on the left, and this is actually US 25, that's actually being coming up for a resurface job now. but they retained the existing US 25 on the right-hand picture. It had a crown point between, you know, the southbound and the northbound. So they just basically leveled it and topped it. Reeves actually did it at that time and left a crown point between the two lanes. But the new side, they got a 2% across both lanes, which is the typical that we typically have now, normally have with new construction projects. But you can see the condition of the old side that was just leveled and overlaid in the right picture, and the condition of the new side where water's actually been crossing the joint on the left-hand side. So that tells us how much of an impact water crossing a joint. Because a crown point, water might still get in it, but it's not crossing it and it's not going to damage it as much. It's not as big of a weak area. But on the left-hand side, the new construction side is failing before the old side, where the existing profile was retained. So basic tools needed to ensure proper profile is obtained. First of all, you got to have a straight edge. Every job needs a straight edge. Need to keep it as close to the paver as possible. A minimum 4-foot level, smart level preferred. A string line long enough to pull across the entire roadway, not just lane width, and a tape measure of some sort. So, you know, if you're out paving and the job is surface treatment with a leveling course directly after the surface treatment placed, and then 1.25 inches or 135 pounds of 9.5 on top of that, and you put your surface treatment and you're leveling down, and you're meeting the spread rate, everything's good, and you realize that you still got quarter crown, like this straight edge is showing. You still got ruts, like this straight edge is showing, and you got to come in and you got to put 1.25 inches of 9.5 on top of this. We're not going to have consistent thickness all the way across. We're not going to have consistent thickness. We're not going to have consistent texture. We're not going to have consistent texture. We're not going to have consistent density. We're not going to have consistent density, so we're not going to have consistent performance. So everything about asphalt construction is about consistency, continuity operations, consistent thickness, consistent temperature, consistent force of material up under the paver screed, like Mr. Rogers talked to you about. So that's the key to quality, is continuity and consistency. So at this point, we know we're not going to have enough quantities. We're probably going to have some density issues with the 9.5 that's going on top. We're probably going to have some spread rate issues as we pave. There's going to be some places where the spread rate will probably be high. Some places the spread rate's probably going to be low. So this is when you get people together. You pick up that phone, call a friend, call a cab, get some help, spread the love, spread the word. This is what we're going to run into. Let's talk about it. Is there anything we can do? Have we got, can we bump the thickness up to 1.5 inches of 9.5 instead of 1.25 inches? Have we got the extra money? Did we save any on the patching? Did we save any quantities on the leveling? Do we have enough, or should we take some of the leveling and put it in the topping? Come up with a plan, because once it's covered up, the problem is going to be the problem. So straight edge tells me a lot. You can use pennies, you can use a rut wedge, you can put a block on the bottom of it and tape it, 1/4 per inch or 1/4 per foot would be a 1-inch block to get it back to level if you don't have a smart level. But knowing your cross slope, ensuring that you got positive drainage, knowing that you got consistent slope across is very important. So you can see right here, this is a job that it looks like didn't have enough quantities, didn't have sufficient quantities. And you see that there's a difference in thickness all the way across of the surface mix. When a paver put it down, it was probably flat. But when you paved it, because there was a bad rut or a quarter crown, the mix in the bad rut got bridged over. So you got 13% air voids within 2 foot of 7.8% air voids. So these are the kind of things that happen when you don't have a consistent thickness or a consistent flat surface to put your surface mix on top of. So putting a straight edge, checking it out, making sure it's flat before it's rolled is important, but also putting that straight edge down after it's been rolled to make sure that it is still flat is very important too. Take your level, put it on your straight edge. If you don't have a smart level, easy way to check, quick checks. So you can see right here, inverted center line, using a string line, pulled all the way across. Took my level, or that was actually one of my pictures. I take my level and slide it up under the string line. So you can see that the joint's open. You can see where the water actually got into the pavement and started causing premature failures in the wheel path. And the discoloration that you see like that, that's a sign that water that could be inducing stripping. So that discoloration is a sign that there's some water damage down there somewhere, most likely between the surface mix and whatever layers up under. So I think that's everything on joints. Any questions? So we haven't got any questions that we know of yet, but just one thing I want to leave you guys with is always remember that being proactive and talking about problems and dealing with a problem before a job is done is always the best way. Partnering, communication, there's always a way to figure it out. Just taking the time to do it and, document, talk. Make sure the project's delivered on time. Make sure that nobody has to go back and fix anything. That's always good for everybody's business. All right.
Yeah, how about this question? Say on a 2-lane crown, would staggering the joint move your crown and affect quantities?
Well, you'd want to stagger just a little bit with your leveling layer or whatever layer you're going to be using, whether it be OGI, which will be leveling. But for the most part, at the crown point, you don't need to try to stagger the foot. That would only be, when you've got a consistent cross slope all the way across. You can stagger a little bit, but not whenever you've got a crown or a break. Did that answer your question?
It was one that was posed. I see no response, so I'm assuming yes. And I'm not getting any more questions, so I think we can move on. All right, so the question is, with the 10-foot straight edge, could you explain the process of checking a joint before rolling material?
So the question is what now? The question was, with a 10-foot straight edge, could you explain the process of checking a joint before rolling the material? So if you laid the straight edge down on the hot mat that you're pulling off or pulling, you want to make sure that this doesn't have any knots or irregularities or the screed fell and it popped right up. And you can also look at the gap on between the hot and the cold, and if it looks consistent, then it should consistently roll down all the way across from side to side. I hope that answered your question.
Josh, you gonna introduce the afternoon session?
Yes, ma'am.
Okay.
Good afternoon, everybody. Thank you for coming back for the afternoon session. The next presentation is going to be about compaction, and this is going to be Miss Sheila Hines.
Thank you, Josh. Good
You're
afternoon,
welcome.
everybody. We appreciate you being here, and we've had some really good presentations already. We've talked about some of the can't talk. The beginning requirements before you start paving, such as cleaning and tacking, and then the actual lay down aspect by identifying the parts and the functions of the paver. And then Tony Felix covered some issues that you might see with the paver and what to look for. I think it was really great. And one of the last parts of the paving operation, but certainly not the least important, is when we talk about compaction, when we talk about actually going out and rolling that in-place mix and going for density, but we also get smoothness with it. If you have a poorly densified mat, you're going to end up with a poor smoothness, and it will lots of times be an indicator. It also can be a determination for blemishes and such. For instance, segregation that has been talked about already can lead to some of the issues related to density. So I'm gonna go forward. So what we have here is we're showing some of the basics as far as the I'm sorry, I need just one second. There we go. Some of the basics. We have the breakdown roller, which is a steel roller, and it normally goes in a vibratory fashion to get compaction. You also have the rubber tire showing, which is typical place in a paving operation. It is not the lead most of the time. Some of the critical factors for the compaction process, the biggest one is temperature. Temperature pretty much controls all. It has to be geared towards the season. It has to be, which I'm meaning is the weather circumstances. Naturally, it has to be geared towards the mix type, and it also has to be geared towards, in conjunction with the mix type, the type of AC you're using. So if you're out there trying to put down an SMA mix or a 12.5 super pave that has polymer modified liquid, you would use a higher temperature. Because of the stiffness of those mixes, they have the tendency to get colder faster, and they also get stiff, and you lose that lubrication ability that you get with conventional AC to be able to compact and put the mix together. You want to make sure that you're monitoring the temperatures throughout the compaction process. Not only that, but the entire paving process. It's really important that, and I know it's been preached to you all day about consistency, but if you want a good, acceptable, consistent in-place mat, then the better consistency, the better uniformity you get, the better it's going to be. If they're putting down a thinner mix like a leveling or a 4.75 or a 9.5 type 1, you have less time to achieve compaction. With the thicker mats, such as a 25 millimeter or a 19 millimeter, you're putting down a larger mass of asphalt for the lift, and so it will hold its temperature longer. So thinner lifts, you have to be on it and compact it sooner. A good tool to have out there is one of the infrared temperature guns. Now, the only thing is that we always have to keep in mind is what we're getting basically with that is a surface temperature. But a surface temperature is a pretty good indicator, because if your surface is 296, then typically, depending on the thickness of the mat, the material underneath the surface may be a little bit warmer. So having the infrared temperature gun is a quick and easy tool to use out in the field. Typically, compaction, you want to do it at higher temperatures. We're saying here 240 and above, but again, it depends on the type of mix. If you have how much of the mix you're placing. If you're placing a thicker lift and it's let's say you're placing a 2-inch lift of SMA, then that you definitely are going to want warmer so that it'll go together better. But you don't want it too hot. If you get onto a mat when you're rolling and you've got a high temperature, let's say outside, what the tolerance is. Does anyone know what your job mix formula temperature tolerance is out in the field when they bring that mix? And I can't see the question, so I don't know if you've answered it or not. But basically, whatever your job mix formula is set at, and typically for non-polymer modified mixes, it's going to be around 300. So you are allowed plus or minus 20 degrees. So you can go basically from 280 to 320 on the truck when it comes to you. And so if you've got a thicker lift of asphalt or a polymer modified mix type, then those you definitely want to get on it with high temperature. Sometimes thinner mixes and also finer mixes, though, with high temperature, you can have problems where it starts moving underneath the roller. And in those cases, you can back off some, opposed to what people typically say is you're always bumping the paver. That's fine unless you've got a tender mix, and then you're going to want to back off and hold the rolling and the rollers back just a little bit and let the mix cool down. With that said, you do not ever want to be placing really super hot mixes that are well above the job mix formula temperature, that tolerance. So if you were to be placing a mix that where your job mix formula temperature was 300 and it's out on the truck at 350, 360, you don't just set it aside and let it cool down. In that case, it's probably damaged your asphalt cement. So that's when you hate to do it, but rather than put in place inferior material, you have to reject it and send it back. There are 5 basic ingredients to the compactive effort. One of them is static pressure, and that is just the weight of the machine. That's just the forces that the weight of that machine is applying to the material. Impact is like an exerting a force like a hammer, which will drive it down. It densifies it by hitting it, impacting it. Vibration, that is the energy that resonates in the material into a state of equilibrium. And basically what that means is when it goes out there and it vibrates, it's kind of giving you a different orientation of the materials and fitting it all together. Frequency in rolling operation, that's the rate at which a vibration occurs. So your vibration and your frequency go hand in hand. And then manipulation, mending, kneading, that there's really only one roller that gives you this type of action, and that is the rubber tire roller. And again, in Georgia, we do not use the rubber tire roller as breakdown. One of the reasons is they do have like oscillating rubber tire rollers that could possibly be used in breakdown operation, but there's problems with getting smoothness when you put the rubber tire in the front as opposed to that nice uniform steel-wheeled breakdown roller. The compaction phases, they go into 3 basic ones. You have the breakdown roller, typically done with a vibratory steel roller. You have the intermediate, which is it could be a steel roller, but typically it is a rubber tire roller, except for some of your, sometimes like with SMA, you wouldn't want to put a rubber tire on the mix because of it being highly polymer and all the fines in it. And then you have your finish roller, which is it's there just to remove cosmetic issues such as roller marks that the other rollers might have left into the mat. Understanding asphalt compaction, well, the main thing you need to realize is it all goes together. Your mix design if you want to get good compaction, you have to make sure that you have a workable mix design. One of the things I think that Tony was talking about is where Georgia has gone to what we call the corrected optimum AC content, the COAC. And basically what that is we've put more neat liquid into our asphalt mixes that have wrap, because we don't think the wrap really contributes that much to the overall the wrap AC contributes to the overall mix. So if your liquid is too low in your mix design, then you're not going to get a good uniform consistent compaction. Same thing if your gradation is wrong. Let's say the mix is too coarse. You probably will not get the compaction you're hoping for. You're introducing interconnecting air voids. The asphalt cement type, we talked about that. A polymer modified liquid is harder to compact or put together than a non-polymer modified, because the lubrication, you have a higher viscosity, which affects how lubricated those particles inside the mix are and how well they'll go together. Different types of modifiers and additives. Someone asked about cold mix. I personally thought they might have been talking about warm mix, but I may be wrong in that question. But warm mix affects compaction. Some people just use it as a compactive aid, like if they have long hauls or in the winter months, it provides a longer window to be able to compact the mix. I've talked about it, lift thickness. That is a factor. The base conditions. Is the base sound? Does it give? You know, if you don't have a stable base, you will not achieve compaction. We've had, and another thing is like in some of the towns, in small rural towns, where they've got water pipes and such right up, you know, near the surface. And I can't tell you how many times that we've gone out there without understanding what was underneath the roadway and broken pipes trying to compact and put the mix together. So all of these play into a factor about not only how well you can compact, but how you actually need to compact. The air temperature and wind as well as rain. And naturally, we know we don't want to be paving in the rain, but if you've got a really blustery day and a lot of wind, that's going to make your mix cool. If it's cold, then you're not going to be able to get the same density you can if it is warmer. But with that said, if it is super hot and you've got, you know, a really warm mix out there, you might get some of that movement of the mix, where we've talked about earlier, where it may not be stable, and it starts waving out on you, pushing out ahead of the roller. Talked about the vibration and the rubber tire roller. We'll go into more detail with that. And a rolling pattern. GDOT used to always give rolling patterns out on projects. We don't anymore. That is typically left to the contractors, their responsibility, unless they specifically request it. Lots of times it got to the point that, you know, the contractors were having their own gauges out there on the road. And since they're responsible for compactions, they wanted to have their own people out there telling their crews how to roll it. So in a lot of ways, GDOT's recommendations for the rolling pattern became more of a hindrance, you know, more of a liability, especially for the contractors, given the fact that, you know, they're held responsible for achieving compaction. So we've got all of these factors that play into compaction, and they all have to be considered. We talked about static pressure, and basically when you are using a non-vibratory roller and you just got the weight of the roller out there, density occurs from the top to the bottom, so it compacts itself down. If you've got a thick mat and you're trying to put it together by static rolling, sometimes you can't get the density you need. You can't get those lower in place air voids, because it doesn't translate, that weight or that force from the top won't translate all the way down to the bottom of that mat. So that's why we typically, when we're out there, we're using those vibratory rollers. But with the static pressure, it can vary. You can get the very same type of static pressure from a smaller roller that may be heavier than a larger roller, because it all has to do with the contact area. PSI, I mean, the pounds per square inch, that is what you're talking about. So a lighter roller with a bigger wheel will possibly not give you the same effort as a smaller, heavier roller with a smaller wheel putting more PSI on the mat. Impact, that's that hammer effect that we talked about. And rollers are adjustable. You can have a large impact or a smaller impact. And it all has to do with what's called amplitude. With a really thicker mat, like a 25 millimeter, you're going to want to have a larger amplitude applied, more force being applied than you would with a fine mix, like a 4.75 or a 9.5, or maybe even a 12.5. So the thicker, the coarser, the bigger the rock, the more amplitude on that breakdown roller, the type of force that will be applied, and the finer the mix, the smaller the amplitude. And basically amplitude is like kind of like the moving kind of the drum. It's like the bumping effect or the hammering effect. It's the vertical distance that drum is going to travel. The vibrations, that's like we said, with the vibrations, your compaction, you are taking the material and giving it a different orientation. You are vibrating it into place, and it occurs from the bottom to the top of the surface. And it typically will give you better compaction than you can get with a static type pressure for compaction. Amplitude adjustments are available again in all rollers have an amplitude adjustment of some type. This one is showing where you can adjust it to 8 different settings. Now, most of them don't give you that much of a variety, but they have to have the ability to affect how much pressure or force is being applied on the mix, because of all the different properties that are affected in the compaction process. This is just showing you the inside of the drum, how you've got the different adjustments where you can adjust your amplitude. The other one showed with the wheel that adjustment was actually on the drum wheel. This is showing just the different gauges, and this kind of gives you an idea of how that impact, that amplitude is adjusted. That center piece, let's see if I can pointer option there. This center piece and this wheel, the less force you have, the more towards the center this inside weight is. So as you move the more you move the weight away from the center, the more impact that is applied. It's kind of like, swinging a weight on a rope. The closer it is to you, the less force. But when you give it a little length and really swing it out, it would do more damage. It's the same type of application with this. Again, just a clarification of the way it's different weights that are swinging around in the center of that drum. Frequency, I've talked about that. That is how often the impact is going to occur. And for asphalt, you typically are always going to want to be on high frequency. Soils, you typically would use a lower frequency. Now, there are rollers now that are being made that adjust the frequency and the amplitude as it rolls. And it's kind of picking up a stiffness measurement that is that is within the mat, and as it picks up, as the mat gets stiffer and stiffer, it starts reducing the amplitude and the frequency. These are automatic. This is like intelligent compaction technology. Georgia does not require intelligent compaction for asphalt. I don't foresee Georgia anytime soon ever requiring it, especially for an acceptance type possibility, because I don't think the technology is there yet. But some contractors have chosen to use some IC on their rollers, and just to kind of give them an idea, a number of things that it shows on top of the stiffness or the measurement of compaction via a stiffness measurement. It also tells you roller passes and shows them on a little screen on their roller about where they have actually traveled. So, I mean, that's not a bad idea, but hopefully your roller people are keeping up enough to know what their roller pattern is and making sure that they cover it adequately. Another give me on the frequency is on a lower frequency, your impact spacing is further apart. As you can see here, this is a lower frequency, this is a higher frequency. And this is really important, because if you have your impacts too far apart, you don't get the same effort across the entire mat, and it will show up within the mat. Another take on it. One of the things that can also do it is you can have your frequency on high, but then your roller is traveling too fast. So if your roller goes too fast, then you end up not getting that close together, those impacts as close together as you need them. And typically they say, you know, 10 to 12 impacts per foot as a rule of thumb. But you want a consistent, not typically, I'm not saying slow, but a medium speed for your roller. You want your roller to be able to keep up with the paving operation, but you don't want them just, you know, running really quick so they can then pull over to the side and, I don't know, you know, have lunch or whatever. You want it to be a consistent, steady speed, not too fast, not too slow. Because either indicator will show you can have problems. I think you can see these ripples that are in the mat. And sometimes, like at night, if you look at it, I've seen it under lights, and it would look like you've got, you know, a protruding like corrugated effect on the mat. But when you go over and fill it, or you stick a straight edge on it, it's not really there. That's an optical illusion. But you can indeed have those impact markings if you're not careful. This is showing a straight edge, and then as a close-up, you can see the little areas of daylight underneath it. And that is because of a couple of things that could have caused it. One, the roller was going too fast. Two, the frequency was too slow or low. And three, maybe your impacts, you know, the amplitude was way too high. So there's a number of factors that could have caused this. But in this, you don't want it. Have you ever ridden down a road and it sounded like it was roaring? And I'm not talking about, you know, out on the outside shoulder. I mean, actually in the middle of the road. That could have been because of the way that it was compacted, and it comes back to haunt them. On a lot of the rollers, they have a kind of what they call the green zone. And it's basically just giving them an idea of where they want their impacts to be. And as they roll, they try to keep this needle within the green zone of 14 to 10 impacts per foot. And some rollers have it, some don't. It's just, again, depending on the suppliers. This is another indication, if you can see this picture, of where you've got impact marks. And some other factors could be that maybe the mix was already too cold to be out there rolling it like that. I've seen that before happen. It's no longer warm enough for that AC to be lubricating. It's now too stiff and it's trying, to congeal and hold that mix together. Using too high of an amplitude, or the frequency again is set too low. All of these are factors. They're very important, and to watch it. And that's one reason why, if you're out there as a GDOT inspector on a roadway, I know you're supposed to take up tickets, and I'm not ever going to fault anybody for doing that. But walking behind the spreader is a good idea, but also walking behind the rollers is even better idea, because that gives you a good indication. Lots of times those paving marks that you may not see directly coming out behind the spreader, once they get on the roll, once it's been rolled, it'll let you know, was that a temporary or was that a permanent problem? And that way you can therein address the issues that are a permanent problem. You want to make sure that you're using the appropriate drum width, that roller is right for the type of mat, the mix, the width, all of those that you are paving with. And as an example, it says that a 12-foot wide mat is covered efficiently by an 84-inch drum using 2 roller paths. That's good. Or it can be done with a 56-inch, but you're going to have to make 3 rolling patterns. And that again ties into what type of paving speed are they wanting to maintain. So if they're wanting to be able to get a little bit more production, they're probably not going to want that smaller drum that they'll have to get 3 roller paths with. They'd probably rather go with the bigger one so that they can make that in 2. All of those things go into play. I guess the real thing to remember is, if you're out there paving and your paver is way ahead of the roller, there's an issue. It may be that you need another roller on the project. It may be that there's a problem with the roller. It may be that it's not the appropriate roller for that situation. But the roller should be pretty close, right up there with the paving operation, and you never want it to be significantly behind. Those are the type of things that we need to be looking for. It's just showing a pretty good idea. The paver's up there with an MTV, and the roller is up there with it, making the roller pass. Again, making the roller pass. And this one, if you notice, they're right on the edge of their where they're compacting into that joint. So they're probably trying to do some breakdown on this one, trying to crunch in that asphalt into that longitudinal joints. And I'm not going to cover joints. Go to jail, but no, I'm not going to cover joints, because Tony is I think did a really good job in his presentation. But that kind of puts into play about how important the compaction is. In this situation, if they were to wait until the mix had cooled to get over there and try to roll in the longitudinal joint, you're probably not going to have a very dense joint. You're also probably going to have an overlap of some sort, where one side of that joint is going to be a little bit higher than the other, and neither of those are a good situation. You want to make sure that when they're rolling, that when they're coming to a stop or a slowdown, that they do a turnout, that they curve it a little bit. You don't want them ever rolling up into a dead stop. That has a tendency to push the mix up into a wave, which will cause a bump into that asphalt. And lots of times you can't roll it out. Sometimes it'll even cause a crack, some sort of cracking into the mat when they do that. So they always should do a little bit of a turnout when they're coming up, slow down, stop, or begin their backup pass. If for some reason they have to stop rolling, let's say the paver stopped for a minute, or they're waiting on trucks and they don't have a good consistent paving operation, and they've decided to slow down or stop, you want to make sure that they don't stop dead on. Again, just as when you do that turnout, when they're actually rolling it, when they sit on a mat, if they're sitting on it dead on, you would have the more tendency to be able to feel that bump that it makes cause in that in place material. But if they turn at a slight angle, it does have the tendency to reduce any damage that they may do with just the weight of the asphalt, the weight of the roller on that warm asphalt. We have seen and we have done tandem breakdown rolling, where you have more than one roller in the paving, paving path behind the spreader. I think I originally saw this a lot when we first started doing SMA, because we weren't that familiar with it, and we were just learning, and we would get out there and do some tandem rolling. Typically, when I see it now, it is more into this fashion where you've got them a little bit side to side rather than front to back. And this, they can cover a mat, especially if they're pulling a wider mat. They've talked significantly earlier this morning about extendable screeds, and I'm not gonna address that. That's not in my presentation. But I will say this, that if they're pulling a wider mat, in that case, you might want to go with your two rollers like this in a side-by-side fashion. That way you can get it and get compaction before anything cools down. If you're rolling a mat where you've got like a separate shoulder that has got a different slope, and that's pretty common for us, then some contractors have opted to put a smaller roller that's just dedicated to that 4 foot, 6 foot, whatever, outside or inside shoulder, to roll it separately. And that way they're trying to maintain the proper slope, because if you go crossing over from your main line onto your shoulder, you have the tendency to be rolling out your slope, and you don't get the slope that possibly you were supposed to, that it was designed to put in to that shoulder, because your shoulders do normally have a little bit higher slope than your main line does. Talk about rolling crown. This is just a rule of thumb where you start at the bottom on one side and go over. We on 2-lane roads, yes, we put in some crown. Other than, the type of crown they're talking about when they're trying to get a good consistent matte texture, a lot of the paving we do, we don't put in a whole lot of crown in the road. But again, a 2-lane road you will, because you want to make sure that you get that proper drainage. Just showing again a close-up of a roller. But the thing that you might be able to see here, it looks like he's over on this joint a little bit, but can you see the daylight underneath this wheel? And what is happening, it is bridging. This roller is bridging over up against this joint. And what will happen is, no, we won't get a good joint density along the longitudinal joint like we hope to, if you bridge it. So in that situation, you would want them to come back and actually roll where you don't get this daylight showing through. Because the weakest part of any of our roads is going to be the joint, whether it be our transverse joint or our longitudinal joint. That's where we typically see our failures on our roadway first, is along those joints. And if you're not getting the density right up against those joints, then they are more likely to fail even sooner. So compaction is really important. You want to make sure that you don't, and this is ugly, don't look at this. This part's ugly, but can you see all the white capping or the crushed aggregate? When you see that, you've got a problem. And it could be a number of things. It could be the roller's too big for what you're doing. It may be too heavy for the material being placed. It could be that they're over compacting it. It could be that the amplitude is too high. It could be that the mix is being placed too thin. there are a number of issues why you may have crushed and fractured aggregate. But I think the key that what we want to know is let's just notice it and don't let it continue. Just other things. Rolling open graded friction course, which is we put a lot of OGFC, used to use PEM, but we're now pretty much all using OGFC, is when you roll it, you're not going for density. You're not rolling it to get put in place low air voids. Basically, with an OGFC, you're just setting that mix in place. You want it to be able to, Josh talked about heavy tacking underneath an open graded mix. That's because you don't have all the contact with an open graded mix that you do with a more dense graded mix, where you've got all these spines in between. And when you can use a lower tack, and it will adhere very nicely to the underlying lift. An open graded mix doesn't have that same capability. It's more open graded, and so you want to make sure that you got that heavier tack application. And then when you roll it, you never want to vibrate it. You will never vibrate an open graded mix. If you vibrate an open graded mix, then you have defeated what is out there for you. You won't get drainage. The other thing is see how big this roller is? I think sometimes contractors, because they only want to reduce their number of passes, and I'm not saying it's a bad thing, I understand it, but sometimes that roller is not the best choice for the circumstances. And when you see a large roller like this, especially on a thin lift, because OGFC is placed where it's only like an inch compacted, and it's basically rock on rock almost touching, you will see white capping. When the downtown connector was done a few years back, the district assistant district construction engineer called us out there to look at it, and one of the things we saw a lot of crushed aggregate, and we saw a lot of white capping, and it was partly due to the fact that there was a big roller on it that probably shouldn't have been on it. So that's one of the things we need to look for, DOT and contractors. So maybe the quickest is not always the best, while we understand, wanting to do things in an economical and efficient fashion. I mean, because that's a win-win for everybody. But sometimes we got to back up and punt. So when you're out there rolling OGFC, we want to make sure that we've got the right roller for the operation. And anytime you see white capping, especially on OGFC, we're doing something wrong. Either we're vibrating it, we're rolling it too much, or maybe our roller's not the right size. OGFC is designed for water to go through it. And that's what we're showing here. This is an old picture. And I don't know that it's ever done anymore, where after you put down some OGFC, I don't know, they might, especially maybe in South Georgia, where they'll go out there with the water truck and put some on it just to see if it drains. And I'm not saying it's a bad thing. It gives you a good idea if it drains or not. But what we want to say, please remember, it has to drain. Now, some of the reasons why we stopped using PEM and we went to OGFC is because, yeah, PEM would drain like a funnel. It would drain, but it did not last. It didn't have the durability that was needed. We were out there redoing projects after only 6 years with some of the PEM mixes, and that was a coarser mix and it had higher air voids. So while we have recently fined up our open graded mixes, and we have recently changed some of the design air voids so that they are lower, they still drain. They still drain after 10 years better than a concrete pavement does day one. But in order to also be able to get a lifetime service out of that mix, we fined it up. We put a little more liquid AC in it, and then we've also knowingly reduced the required design air voids. Pneumatic roller, that's the manipulation, that's the kneading effect. They are normally in the middle of the rolling operation. They are pretty helpful. If you are just on the edge and not being able to get proper compaction, sometimes a loaded rubber wheel tire out there will put you over the edge and give you what you need. It is manipulation, similar to how super paved mixes are designed, and they work. They, even if you've had a, maybe a little issue sometimes, out there rolling the rubber tire sometimes can, heal up the mix a little bit. Talking about wheel oscillation, and basically that's what it talks about, is the movement of the tires being able to go in, and they need the material with a K, not an NNED, and they reorient it a little bit, but there's not much because your vibratory roller pretty much should have done that. So this is just closing up the little bit that's left. It is basically based on ground pressure, and that has to do with added weight and what you may be applying to the wheels. You want to make sure that the tire is inflated properly, and they all are inflated to the same. If there's inconsistent tire pressures, you can see it lots of times right behind that roller. The rating contact area, that's all manufacturers, and that's not something we expect GDOT folks to go out there checking on. I mean, they don't typically do it. But if there's a real problem with a rubber tire roller, lots of times you'll be able to see it behind them. And one of the biggest issues I've seen is where we're putting it on the mat too quick, and we start getting a lot of roll down, and those, once you do that, it's kind of hard to be able to get that out. So you want to make sure that your rubber tire is at the right place in your rolling operation. The overlap is so that you get a consistency. There typically are 5 tires and then 4. And so you want a consistent overlap. That's why you want to make sure that it's properly inflated. If it's too inflated, it'll be more of a narrow pass than what you want. If it's underinflated, it will be wider and won't give the same effort of the pressure for compaction. Talking about roller tire marks, this could be good or bad, but this isn't what you want to see after they're done. When you start seeing this again, it may be your mix is too hot, you're on it too fast, you didn't get compaction with the steel wheel roller. So you want to make sure that the rubber tire there is to help, not hurt. Just some reasons that could be doing it, causing this. This is an example. And one of the important things about a rubber tire roller is you want to make sure you've got the brushes on it. And I know sometimes contractors bring out some really old, machines, and these are half hanging off or are off. But you want these because what they help do is they help keep the fines from building up. Because when the fines start building up, you see these little drop-offs. These will roll into the mat, and they look like little sand patties on the surface, and it's just AC and fines. That's all it is. And it will, I don't know that structurally if it will really damage the mat, but I do know that it is one of those things that will get you public fuss and phone calls. So if you have your brushes on, if they keep the tires hot, you normally are okay with the rubber tire. Just showing the rubber tire and the rolling operation. This is a rubber tire up front. They're in between. The breakdown roller is in front of it, and then you've got the behind will be the finish roller. Another issue. This is not what you want to see. When you see this, stop it. Don't allow this to happen. And I promise you, I don't know that I've ever seen a contractor who wanted to keep doing this. to be honest with you. I mean, they don't want this any more than you do. So when whoever sees this first, they need to, step out and say, whoa, we got a problem. Finish rolling, again, it is for cosmetic. If they're getting compaction behind the finish roller, then we probably haven't done what we needed to do with the first 2 rollers. They are there to take out roller marks and just give you a nice consistent cosmetic finish on that in-place asphalt. Just different views. Again, they're back there by themselves most of the time. In this picture, you can see the other rollers are way up ahead and they're just sitting back here. A couple of do's and don'ts with the breakdown roller is you want to make sure that the water, not only the breakdown roller, but your finish roller too, and even sometimes with the rubber tires. Some of them have water systems too, but definitely with your breakdown roller, you want to make sure that all the water spray nozzles are functional. You need to get water on those steel wheels that are breaking down that mix. If not, you're going to start getting bad pickup, and there is nothing that will make a brand new in-place asphalt roadway look best than a lot of roller pickup marks. It is terrible. And most roller operators, when they start seeing it pick up, they're going to stop because they don't like it either. But stopping and just, scraping off the asphalt that's leaving it is one thing. Making sure that the spray nozzles are working, that's something else, and that's something that we all should be looking for. The other thing is you want to make sure that on top of the nozzles working, that there's like a metal blade that goes across the roller, because that metal blade is what actually spreads that water across the entire roller, the full width, because that's very important, as you can see in this picture. That is what will prevent it from picking up. I know that way back when before Jesus was born, I'm teasing, when I was out on the roadway myself, and we were doing some of our very first rubber modified mixes, and we were putting soap in the water in the rubber tire rollers, because of the fact that that rubber is not how we do rubber now. It's how we did rubber then, was picking up so bad we couldn't stop it. So not only did we need all the water we could get, but we were actually putting detergent in it, trying to help. So your rolling operation is vital. It's vital for density, and it's also vital for the smoothness, because if they're not rolling it consistent, you will not get the smoothness you're looking for also. I've got some questions. So where does a roller need to be sitting when not rolling, if possible? Off on the side of the road, right? I mean, if it shouldn't be on the mat if it's not possible. But if it is not possible to be off on the side of the mat, how should it be sitting? At that angle that we talked about earlier. If rollers cannot keep up with the paver, what should be done? You only got 2 options, don't you? You either slow the paver down or you bring another roller out. 2 options. What roller gives the most density in the compaction process? It's the breakdown roller. It's that front roller. You typically are going to get more than 90% compaction out of that breakdown roller. That in conjunction with the screed itself, the paving screed itself. What happens if the mix cools and becomes too stiff to densify? One of 2 things. Either they end up with a pay penalty if it's still within an acceptable range, or it comes out. Once it's in place and you can't densify it, it's too late. Base preparation, again, I just want to talk about that just a little bit of a second. I'm not going to go through this. I just want to show you some pictures. These were taken off GDOT projects. And when you see this type of cracking in a base layer, it could be sometimes, rarely. It could be the base mix. It could be the 25 millimeter. Maybe it's too tender. Maybe it's too dry. There's not enough liquid in the mix. But typically it's going to be because what is being placed on underneath is not stable. That either it rained on and destabilized it, or it never was stable to begin with. And so when we're out there and we're trying to roll it, it's moving. And when it's moving like this, that is something that you know you have a problem. This is not a problem you want to cover up. This is a problem you want to address and fix. So if you see something like this, let somebody know. Here, this thing says it may be a permeable mix. Well, if it's a permeable mix, what is that telling you, especially if you got staining like this coming through it? Typically, it's permeable because you've got a problem underneath it. And so that, again, is something you want to look at. And I mean, this again came from a GDOT project, and there was a problem. They ended up, having to remove and replace some of the stuff. When you have rutting in that underlying material, it's either you got a problem with your mix or what your mix is being placed on. And you don't want to keep placing and going forward if you've got rutting already occurring in your 25 millimeter. Now, you could say, well, yeah, but we're going to put 2 more lifts of asphalt on it. But over time, things have the tendency to conform to what's underneath it. So eventually, especially if it's base related, eventually we're going to end up with a problem all the way up to the surface. So this is something that we need to be looking into. And not only that, you see the rut, but you can see all this cracking in between too. And all of that truly is indicating you probably got a problem underneath it. Just another view. Now they've cut some cores. They're doing the right thing. They're trying to evaluate what's going on. But you see how the water is running already in the wheel ruts? We shouldn't be getting that on new construction. And so again, something like this should be a flag where we need to say, okay, we've got an issue. We need to do a little bit more investigation. Once you've placed it, it becomes much more expensive to correct it. Not only for the department, but also for the contractors. I mean, the contractors would rather us say, hey, can we look into this? Something's not right. Rather than us to come back later and say, hey, I know I'll let you put this down, but now you got to take it up. So the best thing we can do in those cases is we're not all paving experts, we're not all equipment experts, and we're certainly not all material experts. We all know what we know, but we know enough, hopefully, that when we see something that doesn't look right, that's when we need to say, hey, we've got a problem, can we investigate it? Here, they definitely knew they had a problem. This is already failed on them. So what's going to end up happening? It's going to have to come out. And it's probably not just going to be this little bit, because look how extensive it is. Now, it may be because of here, but this is going to initiate an investigation, which is probably going to be costly. And we know it's probably going to be costly for both the department and the contractor. So with roller patterns, basically, the thing is the contractors are doing them themselves now, unless they ask GDOT, and GDOT's going to go out there and give it to them. And then the contractor's going to roll it. But it's their responsibility. Bottom line, it's their responsibility. Anybody have any questions? Josh, Cyprian, the world, anybody?
I see one here, Sheila.
Okay, we good?
One question.
Okay,
Can you hear me?
I can.
Okay. I've been seeing a breakdown roller with a steel drum on the front and rubber tires on the back. Do these better than your average breakdown roller? Do these compact better than your average breakdown roller?
Honestly,
That one?
yeah. And Jason and Josh, you may want to get involved, but predominantly the only type of construction I've seen those on, but now I haven't been in the field for, a while, but was like in some surface treatment work. But I haven't seen them on a regular paving project. And to be honest with you, I don't know that I would allow them on a regular paving project.
I have actually seen a contractor that's using one, but as far as compaction, they've actually been getting good compaction with it. I probably couldn't tell you if it was compacting better than just a regular using 3 rollers, but they do get passing compactions.
And are they using it as the breakdown roller?
Yes, they're using the breakdown and the rubber tire. No, I'm sorry. Yeah, let me think. Yeah, they're using it for the finish and the rubber tire. Not for the breakdown.
Okay, so they've got a steel wheel. They've got a steel wheel for the breakdown roller,
That's
a
correct.
regular one.
Yeah,
Okay.
that's correct.
Okay, yeah, in that situation you would be okay, but I don't believe I would want it in the breakdown position.
They vibrate. I wouldn't think they vibrate.
I can't remember. I have to check.
The person that asked that, are y'all seeing it on regular projects, and is it being used as a breakdown roller?
Sheila,
Sip-
mics are disabled for the attendees, so you just give it a
I
minute.
know. I thought maybe you could tell me if they responded.
I will if I see it, but there's a bit of a delay we've been experiencing all day,
Okay.
so I said give it however much time you can. If they do, I'll interrupt you.
Okay, perfect. Okay, so I've only got one more little presentation to go. Okay, I'm back. So we're going to talk just in general about asphaltic concrete. Just touch on it briefly. And again, if you have any questions, y'all have done a good job of it. If you'll just put them in that chat, and Cyprian will let me know. So asphaltic concrete always starts with the mix design. And basically with the mix design, you begin with the gradation that you are shooting for using different size aggregates and then additives and asphalt cement. As you can see here, we've got 1, 2, 3, 4, 5, 6 different aggregate sizes, five different aggregate sizes. We've got the asphalt cement, which is the black liquid here. And then we're showing in this little silver container, the top of it is hydrated lime. Now, something everybody needs to know is over the course of the last few months is GDOT has had a policy change where on roadways, non-interstate roadways, with less than 25,000 vehicles per day, is they are starting to allow the use of liquid anti-strip in lieu of hydrated lime. So the characteristics of the mix design has changed a little bit, as in the ingredients, but they are putting the liquid anti-strip in there to address any potential trouble with moisture susceptibility. The basic steps of mix design is you select your materials. Contractors, producers, independent laboratories, they decide where they want to use, what materials they want to use, which quarry they want to use materials, and go from there. They then design the aggregate structure. They come up with their gradation. As guidelines, GDOT has specification bands for each individual mix type, where it has to be a certain percent passing a certain sieve within a band. For instance, for a 12.5, the number 8 sieve, I think, is 38 to 46% passing. And so they design their aggregate structure and their gradation based on those bands that are specified. From that, they will then determine the individual asphalt cement content for each mix design. Once they have their design, their optimum AC in place, if it's a wrap mix, what their corrected optimum AC, their COAC is, then they're going to be doing some performance testing to make sure it meets criteria before it ever goes out on a GDOT road. Asphalt cement comes from a lot of different places, but really the main place that it comes that Georgia uses is in the refinery process, is where they go out there and they drill for oil. And when they get the oil, they then bring it in and they refine that material. Now, there are some natural places where asphalt cement is occurring, such as this picture up on the right of this slide. And this is in Trinidad. It is a lake of natural occurring asphalt cement type bituminous material. But it has properties that we don't allow. There's a lot of it's fairly stiff because it's not just all asphalt. It would have to go through some purifying type effects with it, and just the easiest thing to do is GDOT just does not allow the use of that type of material. We like the refined material. And in the refining process is the crude oil will go in and it goes into these towers, and they are heated, okay, and put under pressure, and different materials come off at different levels of pressure and heating. Your really fine stuff like your gasoline comes off, propane, butane, all those are what they call the lighter ends, and all those come up off the top. Your asphalt cement is a heavier material, and it actually goes through pretty much a second process, which it goes into the vacuum tower and is further refined. And the basic thing is the asphalt cement is kind of the drudge, the bottom of the barrel, basically, is where that comes from. Now, you wouldn't think for what we pay for it that you could call it bottom of the barrel material, but it really is in the refinery process. But with that said, different asphalt cement sources, because of the different crude sources, they are all not created equal. You have some very robust sources that that have a lot of the lighter ends, the goodies. Those lighter ends are the goodies. Those are the things that help make the asphalt cement more durable, less prone to oxidation and aging, where some of the other sources, they've just coked out all of the good stuff. And again, we're totally getting bottom of the barrel, but it meets the criteria. It just is not as robust as some of the other products. Super Pave, which is the mix design and the AC grading system that is used by the Georgia Department of Transportation, is called the PG, okay, performance grading system. And that came and was developed during the Federal Highway sponsored program looking into a better way to test asphalt cement. And with that, in turn, they threw out their mix design process too. But you get basically two numbers. In this case, we're showing a PG 64 minus 22. And the PG stands for performance grade. The 64, that is in Celsius, and it is the average 7-day max pavement temperature. So When they started looking all around and collecting data, okay, and different states, different regions were assigned as their standard different PG grades. GDOT was assigned, according to the SuperPave program, a 64 minus 22. Now, Georgia had gone from using in the old grading an AC 20 to an AC 30. And an AC 30 would be equivalent to a PG 67 minus 22. And so when we first started using the performance grade, GDOT required PG 67 minus 22 instead of 64 minus 22. But over several research projects done by nationally recognized colleges and universities, we found in benchmarking our mixes that they really perform pretty much the same using a PG 64 minus 22 as they did a 67 minus 22. So now GDOT will use either one. You can use either a 64 or 67 minus 22 for standard grade. The minus 22, again in Celsius, is the minimum 1 day coldest pavement temperature. And so what this whole program was designed to do is look at both phases of a pavement's life. You want to see what can we do with the liquid to help address the hottest day, and then what can we also do to address the coldest day. And with that, they ended up with these ranges of PG 64 minus 22. We also use PG 76 minus 22. Those are the polymer modified ones, in case you were curious. So aggregate selection and structure is very important. Now you can imagine you do not want to design an asphalt pavement using aggregate that is shaped like a lot of marbles. Why? Why would we not want to do that? It wouldn't be stable, would it? You couldn't hardly lock it into place. The first loading you put on it, the aggregates would start rolling underneath you and you would not have a stable pavement. That's why GDOT specifications required what we call fractured faces. It's got to be broken. They crush them in order to get the fractured faces of the aggregate so they will actually lock into place. That's what you need. If you had those round stones, you would never get them to lock in place. So you would forever have rutting problems and shoving and movement of your pavement. With the crushed stone, once you get them oriented properly, hopefully, in your rolling process, then they will lock into place and be stable and strong enough to handle the loading by traffic that is being put on the roadway. I talked about SuperPave. Well, SuperPave used a new mix design process, and that was a gyratory compactor. And basically what it is your mix goes into this larger mold. It was a larger mold than we were using. We used the old Marshall, which was a 4-inch mold. This is 150 millimeter diameter, and we're making about 115 millimeter high specimens. And they go into this device, and this head comes down and goes into the mold, and it starts kneading and gyrating in order to compact the mix. That's why when I said that the only roller in the compaction process that kind of duplicates what's going on the roadway with the mix design was the rubber tire, because this is a kneading process, and it goes in and you get your specimens. You then take your specimens and you weigh them. And we do it because what we're trying to do is we're trying to determine density and in turn in place air voids. Because when you design a mix for all SuperPave mixes used in the state of Georgia, in order to achieve your optimum AC, we're looking for 4% in-place air voids for your optimum AC. So as this example, you can see for this specimen, we use 4% AC. We then checked the density of the theoretical, how much the pill was, and came up with 4.7% air voids. That pill that we designed had 4.7% air voids. We then took another point at 4.5% AC, and typically that's what you do. We normally take 4 points of AC where we're changing 0.5%. 4%, 4.5%, 5%, 5.5, depending on the mix types and the minimum ACs would make you decide where your starting point for your AC percent is. In this case, our starting point was 4. We got 4.7% air voids. We know we need more liquid. We then took another point that had 4.5% AC. We gyrated it, we got our pills, we determined the in-place air voids, and it had 3.3. So we know that in order to achieve 4% in-place air voids, it is between. It's going to be between 4.5 and 4.0. And basically, we just do a standard interpolation. And interpolating between the two, in order to get 4% air voids, it took 4.25% AC. This would be our optimum AC for that mix design, 4.25. And you can bet this probably was a 25 millimeter. It could have been a 19 millimeter, but it probably was a 25 millimeter because GDOT section 828 has the different gradation ranges. And the minimum AC ranges, for instance, for a 25 millimeter is 4% AC. That's the minimum that mixed design can have. A 19 millimeter, the minimum is a 4.25. So while this could have been a 19, it probably was a 25 millimeter. Again, Tony talked earlier about the COAC or the COAC, where when we're using wrap, we adjust the AC content. We do not give that wrap binder, the AC, the old aged AC in the wrap, 100% credit to go into this new mix. We're only giving it 60%. So what we do is we do a calculation, and I don't know if y'all can see this, but if you can, it shows you how to calculate how much that we don't credit. And it's basically 40% of however much that AC is. But that 40%, we don't just say, well, you just don't get it. We require that 40% to be new AC to go into that asphalt cement mix design. And that's why we call it the corrected optimum AC content. And in this case, for instance, we're showing that our original optimum AC, okay? I'm sorry, I'm trying to look at the example to see it. Okay, here, I don't know if you can read this, but the original optimum AC was 5.1% AC. But when we did the COAC or corrected for the wrap AC, we ended with 5.68. So see, that was a pretty significant increase in AC. That is one of the reasons why when Tony and the guys were talking about our mixes have improved so much is because we're putting more new liquid AC. And they make the mixes more durable. They make it easier to compact. They make it resist oxidation and weathering so that we don't get raveling as quick as we may otherwise. After you have your mix design, you have your corrected optimum AC, we then are going to do the performance testing. And in this case, one of the tests we do is the Hamburg wheel tracking device. And this is a hard test, guys. This wheel weighs 158 pounds. And it rolls over these specimens that are in a mold that are placed underwater at 50 degrees Celsius. And depending on the mix type, it will either do 15,000 passes back and forth or 20,000 passes back and forth. And what we're looking at is what is the potential for that mix design to rut. Rutting is very important. You know, cracking is serious too, but rutting is a real safety issue, especially in a rain event. So rutting is one of the most important things that we look at. So we want to make sure that that mix design is rut resistant too. Now, we were hoping to be able to determine a stripping possibility too of it. And there's some questions coming up about, is it actually going to be determined the potential to stripping or not? And that's something GDOT's looking at. They're going to further investigate. But it will determine if that mix is rut resistant. And we know we typically get a little bit lower ruts in the design than we do out in the field with fresh mix. But as long as it stays within our specification tolerances, which is typically a half an inch, 12.5 millimeters. So when they test this on a new mix design, as long as during that 20,000 or 15,000 passes that it does not rut 12.5 millimeters or half an inch, then it's acceptable. I mean, and this is a real torture test. So we feel pretty confident with our ability to determine rutting susceptibility. In Georgia, we've got a variety of mix types. You know, our surface mixes, we got 4.75, 9.5. We have type 1 and type 2, by the way. Okay. And we've got 12.5 super pave mixes. You can't ever use a 4.75 on the interstate, by the way, just in case anybody ever asks for leveling or anything. We've got our open graded mixes. We've got our binder mixes, which are 19 millimeter super pave and 19 millimeter SMA. And then we've got our base mix, which is 25 millimeter. We've got our various pay items. These are things y'all need to know to make sure that the mix that y'all are getting on your project conform to what your pay item is. And lots of times that'll come into play, like when you're supposed to be, let's say your pay item is a 402 4510, which I'm not showing here, but a 402 4510 calls for a 12.5 super pave, group 2 only with polymer. And if they end up not bringing a polymer modified AC, you've got a problem. So it doesn't conform to your contract. So everybody, us knowing our pay items in our contract is pretty important to us. This is just an example of a mix design. The contractor folks, your laboratory people, they'll get this. They'll get it signed and approved. It'll be signed by Jason Oglesby. He's the state Bituminous construction manager, and he reviews and approves all mix designs that are approved by the state. And this is what he'll get. Your project people, you're going to get something similar to this. This is the job mix formula. This is kind of an old-timey job mix formula. As you know now, these things are going into Ashtoware and Site Manager. Jason could answer if y'all are still sending hard copies or not. I don't know, to be honest with you, if they still send hard copies to the area engineers. Jason?
We do. Yes,
Okay,
we do still send hard copies.
Perfect. Thank you. Yeah, so these are what your project folks will be getting out on the field. It'll tell you the mix type. It'll tell you the mix ID number, the gradation, the percent passing, your AC. It gives the theoretical specific gravity, and from that, the tested management folks, when they go out there for acceptance for in-place air voids, they'll use that information. But you should always make, before you start a project, that you got an approved job mix formula. If you don't, then you really don't know what the contractor may be placing. And again, you know, our contractors in the state, we've got good contractors, but there's always that one. And if you don't know what they're supposed to be placing, you don't know what to be looking at when they start handing you those tickets. So job mix forms are very important. Asphalt plants, I'm just going to go through this real quick. Basically, we've got two main types. We got a drum plant, which is like a continuous plant, and it's based off where you've got the drum mixer with this. It dries the aggregate, it mixes the aggregate, it mixes the AC into it, and all your aggregates come out of your cold feed bins. They go into the drum plant. They're heated first, dried, heated, and then they are mixed. For a drum plant, it's going to go up into a silo. We've got bag houses. This actually catches the fines that come up and are caught up in the airstream. In Georgia, most of the fines from the bag house are introduced back into the mix. Silos could be fiber silos. These smaller ones, they could be hydrated lime silos. They could be different types of additives. And then you got your asphalt cement, and this all feeds into the drum plant. This is just showing the cove feeds and then the drum mixer. There's another type, double barrel. A lot of contractors now have the double barrel, and it's set up a little bit different. It's a little shorter, stouter, but it's bigger. And your virgin aggregate will come into one end, and it goes into the outer. I'm sorry. It goes into the inner drum where the flame is, and then it will do the same things. It's going to dry the aggregate, it's going to heat the aggregate, and then it will go into the outer drum, and then the outer drum, your additives are added into it, such as your hydrated lime and then your AC, and it does the mixing there, and then from there it will go into a silo. Just a view of the outer drum with the paddles, mixing paddles and all. Wrap, basically, we get wrap a couple places. One of them is going to be off the road, especially in your metro areas. As you know, we don't raise grade. We can't really raise grade, so we go out there and we mill off on most of our projects before we go in and start laying them. And that's where our recycled asphalt pavement material comes from. Plant waste can also be a part of that, but it all has to be treated, and where we're stockpiling it, we're crushing it, we're handling it, we're sieving it, we're screening it, and then we test it, and from that we determine, can we use it, and then what percentages can we use. Each stockpile in the state of Georgia has to be approved, and not only is it approved, but how much percent per mix design can you use. So some stockpiles may be approved to use only 15%. Other stockpiles may be approved to use 30%. The difference is in the variability. If they're all properly crushed, screened together, then you can normally use a higher percentage of that wrap material than if it's just much more variable in the way that it's handled, where the different ACs sampled throughout the pile varies quite a bit, or the gradation does. Wrap is introduced typically through a wrap collar, which is more towards the middle of the drum plant. It does not go in with the virgin aggregate. You don't want to heat it that much. It's not good for the wrap. It's not good for the AC, and it's not good for the environment. So it goes in at a different point than the virgin aggregate. The bag house, again, it collects the dust. The fines go into bags. The dust does. They pulse. It shakes off the dust. It goes onto the augers, and then the augers then auger it back into the asphalt plant typically. From being mixed, it goes up a slat conveyor that goes over into the silos and is dumped. There is a batching device up here that actually collects the mix into a mass, and then drops the mix into a massive pile, so that it's not like trickling asphalt down, because the more you move asphalt concrete, the more it will segregate, and the less consistency you will get. This is an asphalt plant with a surge bin. And all the asphalt they produce, it goes up, it goes into this batcher, and then it's going to go into this small surge bin. I think there may be one or two, Josh, in the state.
There's one right now.
Okay. Okay. But most contractors aren't going to use this. This is for if you're really going to use a portable plant. I mean, this makes it more portable because you're moving your surge bin with you, where the more stationary asphalt plants are going to be with the huge silos and multiple silos that can hold more mix. This is just showing the loadout situation. You have the silos, the trucks come across on platform scales typically, and they get the mix dropped into the trucks. Batch plant, again, it mixes the mix, but it's a little bit different operation. It's kind of like what it is. It does it in batches. This is showing the screening unit. That's how batch plants were originally done, where you had different screens across different bins, and the way it was normally set up is most of your larger aggregate would be screened off over into a further bin, and then the finer material. What most of the contractors have done now is they have removed the screening unit, and they are controlling the gradation through their cold feeds like they do with a drum plant. And they're putting everything into bin 1, and then it will go in to the weigh hopper, then into the pug mill. The asphalt cement comes in, and it will do batches. But most, I think all of them, now have it where it's designed where they can now put this up into a silo too. So they'll have like a conveyor system that will take those batches and move them up into a silo so that they can be ahead of a game and not trying to do it batch by batch. By running a true batch plant, you probably have the best quality and control of materials. But the contractors, they never get jobs because they can't compete with production by doing it by batches. That's why the ones that do have batch plants and are still running it, kind of run it as a semi-continuous plant by doing it all through the bin 1 and removing the screens. Quality acceptance, this is very important. This is how we pay the contractors, and this is how we assure that GDOT is getting the mixes that we intend to have placed on our roads. Basics, asphalt concrete is paid on a lot basis. Typically, a lot is 1 day's production, but it has to be at least 500 tons. So if it's less than 500 tons, it does carry over into the next day. But that pretty consistently is only like when they're doing some sort of a slow paving, maybe shoulder paving or doing driveways and turnouts or something. Otherwise, it's normally a day's production. The testing is going to be on the 159, which is now going through AASHTO/Site Manager, but 411 should be able to give you a copy of the 159. Pay is based on mixture control, which is AC and gradation, and in-place air voids. And while the contractors are testing for the AC and gradation, GDOT always tests for the in-place air void content. Asphalt concrete lot numbers are sequential. So if there's more than one asphalt plant on a project, sometimes it varies. Like I've seen it where one of the plants will start at 1, and then the second plant's going to start at 1,000. So it'd be 1, 2, 3, 4, 1,001, 1,002, 1,003, and but they will both run sequentially thereafter using their own numbers of series. Mixture control, basically every 500 tons minimum, we take a sample is taken where we test for AC content and gradation, and it is compared with the tolerances and requirements with the job mix formula in conjunction with Section 828. Compaction is per lot too, and it's broken up into sublots. So anytime there's greater than 400 tons that is placed in a lot, which is most of the time, It will be broken up into 5 sublots of equal distance, and they'll go in and test in-place air voids in each sublot. This is showing the 159, how you can go in under there on 411 and find the 159, because I know that GDOT's project people, y'all need the 159s, so you can go on there and get it, and it will give you a copy of the test as long as 411 is working properly. This is in section 400. It is showing the various pay tables. There are different pay tables for surface mix and subsurface mix. So like your 19 and your 25 millimeter has got some different tables than your 9.5 and your 12.5 mix does. It's broken up by a couple of factors. One is the number of tests per lot. So if you've had a high production lot where they ran like 6 tests, your band's going to be different than if you had a slower production where they only ran 2 tests. And it's also based on the variance from the job mix formula. So if it's real close to the job mix formula, then they're probably going to get 100% pay. If they varied a lot from the job mix formula, that there may be a possibility that they're going to be in a pay penalty. This is just showing an example of how that works with your AC content. It starts from your pay factor being 1.0 down to 0.50, and it gives you an option for 8 tests. And this is typically the most tests that you can run because we don't have a table outside this. So that's the way it will feed into it. This is an example. Let's say the contractor's producing 12.5 super pave, and they had 4 QAs. So we look test 1, test 2, test 3, test 4, and it shows what the variance range is. And it said that the absolute deviation of the lot was 0.54%. So when they ran their test, they averaged from the job mix formula how much those 4 tests were equivalent to, and it was 0.54. So we've got 4 tests. So we're going down here and we're looking, and 0.52 to 0.56 falls into this area, and it'll go over. And that is saying, in this case, that would be an 80% pay factor. They would be in an 80% pay factor for this example. Let's say it's the same mix. So that was for AC content. Now let's check the gradation. So it was 4 tests, okay? And it was 7.2% variance from the job mix formula for the absolute average on the 3/8 sieve. So this is telling us it's a 3/8 sieve, okay? So it was 7.2. So we go down here, 7.0 to 7.6. That's 0.85 pay penalty. So on the gradation we had 0.85. On the AC we had 0.80. Which one would we apply? We always apply the largest, the pay penalty, the largest. So, or the lowest pay factor, either way you want to put it. So in that case, if the AC was 0.80 and the gradation was 0.85, we would pay that lot for 0.80, not 0.85. Air void content, basically, we're looking for 7% air voids out there on most of the roads we're going to do for GDOT. And when it's varies from that, then they're probably going to be in a pay penalty. We also want uniform compaction, and there's a possibility of being in a range penalty, and that's where the difference between the highest in-place air voids and the lowest in-place air voids. And section 400 gives you the criteria of what that requirement is. So in this example, the contractor placed the 12.5 super pave. We've already said we're in a 0.80 pay factor because of AC content. 0.85 it would have been for the gradation. And on this one, we're looking, oh, that lot, they had a problem. They got 10.6% air voids in place for the average. So We take the 10.6, we divide it by the 7%, which is our maximum allowed without pay penalty. We multiply that by 100, and that gives us 151.4. So we go over here, and right now we're just looking. This is that they asked for a reevaluation. The contractor has not. So we're looking 151.4. So 151.4 is between here, 149.1 and 172. And that'd be a 70% pay factor. Well, darn. What pay factor will we use now? Gradation was 85, AC was 80, and now compaction is 70. We always apply the most severe. So in this case, for that lot would be penalized where they would be in a 0.70 pay factor. That's it, guys. Y'all got any questions?
Actually, oh, well, okay, someone said no, they don't have a question.
Okay. Well, Josh, I'm going to hand it over to you then.
Okay, thank you, Miss Sheila. Those are good presentations.
Thank you.
That's about all we have, everybody. I know some of y'all was asking about getting credit hours for certifications you may have. Here the next, I guess by next week sometime, I'll send out the certification form that y'all can fill out, send back to me, where y'all can get those credits. Like I said, that's all we have. I hope everybody enjoyed the class, got some valuable information out of it. If y'all got any questions, y'all can just give me a call or Jason a call or send us an email. And like I said before, if y'all got any problems out on the roadway, you can contact our technical services personnel, and we'd be glad to assist y'all.